Tradoon.
Dirter.
Tradoon. 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 Well, hello, everybody, and welcome back to Paleontologizing. A very happy Thursday to all of you, and glad you're here. Happy Thursday and happy Thursday Birds Day. Hopefully, we'll get into that later. I'm actually feeling a little bit under the weather today. Ios stayed home from work yesterday. She was feeling kind of tired, and now I'm feeling kind of tired. So we'll see how long this stream goes today. We'll see if I kind of catch a second wind doing science outreach, because I do find it really energizing. And, yeah, we'll see what happens. Live broadcast. Oh, hello, sweetie pie. Anyway, if anybody's here for the very first time, allow me to introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch doing science outreach. Talking to people about fossils, about the history of life on Earth, about extinction and evolution, the origins of biodiversity, how we learn these things in the first place. That's the whole point of these broadcasts, is to give you an inside peek into how paleontology works, hence paleontologizing. As a dinosaur paleontologist, I work on dinosaurs. Dinosaurs are what I study, what I publish on in scientific journals. Dinosaurs are what I dig up during the summers, and really excited to be streaming that again this year. And dinosaurs, what do I talk about? Or what I talk about 4 days a week here on Twitch, unless I'm in the field doing field work, then it's 7 days a week. But
here's something stranger than science fiction. Prehistoric fact.
Community time, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. Welcome. We've got some fossil news to go over today. We've got some new dinosaurs from Australia. They haven't been named yet, but we'll be talking about why they're important and why they're surprising, why they're tantalizing. Just some scraps so far, but they are intriguing scraps. Shaking up our understanding of dinosaur biogeography during the late Cretaceous. We'll be talking about sauropod dinosaurs from Romania. We'll be talking about the origin of feathers and why it's still mysterious. And whatever questions you might happen to have, don't be shy with those. Do not be shy with those questions. It's the whole point of these broadcasts, is, again, to give you an inside peek into how fossil science works. This is the best way that I know of for how to share this with people. So I'm glad you're here.
Some objects, gorgeous,
Allie J.
and authentic, because though they died out so long ago, their fossil bones remain, so we know just what they were like and can even sculpt them into still, or rather extinct, life.
Good day, Danny DJ Josie.
And good eye to you too, Ellie J. Thank you for the 17 months of support. Thank you for keeping me here online. Believe it or not, everybody, this is how I make my living. This is how I pay the bills. This is how I put food on the table. And that gets easier thanks to good folks like Murph. Thank you very, very much for your ongoing support, Murph. And, Sweetie Pie, look at that Tinamu, very excited. Uh-oh, little too excited. Shoot, Sweetie Pie.
Get out of there, it's gonna blow!
Murph is overloading the system with 10 gift subs.
Thank you, Murph. I appreciate you. I really do. And community time. Is that a first-time subscription right there?
Let's protect our fossils, because
Thank you
if
for
they're
that.
removed, America loses them.
I appreciate that tremendously. Thank you. Community time, you will not have to see any ads. For as long as you choose to stay subscribed, you'll also get access to all of those emotes. These and these and these and these and these and more. And you can rest assured that you're helping support science outreach here on Twitch, and I think that's a big deal. Thank you, community time. Thank you, Murph, for your generosity as well. There's 10 chatters who won't have to watch any ads for the next month. I appreciate that, Murph. Yeah. Good stuff. Yeah. Anywho. Sweetie Pie here, one of my landlords, is demanding payment. She's like, it's the 1st of the month, where's the rent? And Sweetie Pie, it's the 20th of the month. There's 8 more days left in this month. But you know what? I can prorate it out if you want. Let's get you a payment here, shall we? Yeah. All right. There we go. Look at all those. My goodness. What do you think? That's what you wanted, right? What? Ooh. Does it smell good? You're gonna eat those, right? Don't just leave them on the desk. Don't do that. You should eat them. That's what they're there for. Try one of those kitty snacks. There you go, Arle. Yeah, I've got a cough drop I'm working on right now. Took some ibuprofen a few minutes ago. So, yeah, there you go, Arle, yeah. Sweetie Pie being, it's a shakedown. Yeah. Mayor Space says she wants it, but she can't find it. Cats are so bad at knowing that there are snacks right next to them, it's often true. Yeah. Oh, that's Sweetie Pie. Yeah. And no floss. Yeah, Sweetie Pie's never been interested in eating floss. That was Moon Pie. And Moon Pie gets to have her collar off tomorrow. First thing in the morning, I'm gonna go with Lordy to take her to the vet. And she'll get her stitches out, and she won't have to wear the cone anymore. So I'm very excited for her. Although, I spent the whole morning with Moon Pie upstairs, hanging out with her, making sure that she doesn't pull her stitches out, so that she could have her cone off all morning, and she really appreciated that. So we got some quality time together. It was nice to hang out with Moon Pie and catch up on some of this fossil news, and yeah, we're going to be covering that shortly. Anywho. Whoop, where you? Okay. There goes Sweetie Pie.
Look at this graph.
What a beautiful graph. Nate the Web Dev, thanks for the follow. I appreciate it. Welcome to Paleontologizing. Yeah. Good stuff. We've got another cat right here. Another one of my landlords lurking around. It's Minnie Pie. We'll see how long it takes her to jump up onto the desk, but she's circling around like a shark right now. Anywho, I'm glad everybody's here. Sorry I'm feeling a little bit under the weather. Hopefully I'm at 100% again tomorrow, because I was hoping to work on the Spinosaur paper. I want to get that thing done, and submitted ASAP, like before the end of the month. I said I would get it done in February, and I want to get it done in February. So, anywho, Minnie Pie, how are you doing? Hello. You making your rounds too? Yeah. Doing some collecting? It's a nice stream you got here. It'd be a real shame if somebody stole the show. Steal with the camera. I'm sure we could see to it that doesn't happen. But that'll come at a price. Alright, Minnie Pie. Alright. Yeah. And not just one poster, but two. Working on the Twitch. Oh, thank you, Gravity. Holy cow. Appreciate that. Yeah. And Petrodactylus, yeah. I don't know. I set these deadlines for myself because I'm self-employed. But I like to stick by them, even if I don't have a boss breathing down my neck, except for this one. And all of you in chat. know what I mean. Yeah. I love the Archaeopteryx in the background. Thank you, Lenina. Yeah, the Berlin specimen. It's Thursday Birds Day. Thought it was appropriate. So yeah. Yeah, it's so cool that you've got a Berlin specimen Archaeopteryx emote, Lenina. It's pretty great. It's excellent. And Chaotic Time Traveler, how are you doing? Hello. And there you go, Petrodactylus. Yeah, oh, I know what that's like. Yeah. How about we get you some treats, huh? Yeah. Here, I'm gonna mess with your eyebrow whiskers. There we go. All right, give me. Whoa, look at those. Wow. What a delight. Good stuff, Mini Pie. Man, you've got it made, you know? A nice house to live in. Get treats during stream time. Central heating and air conditioning. There's birds to look at outside with the bird feeders. It's a pretty good gig, you know? Pretty good gig. Huh. You have all of these adoring fans watching you right now? You know that? She's like, I don't care about that. And that's why we love her, you know? She doesn't seek the spotlight, it just comes to her. Yeah. You've got some snacks. They already have a package ready with a dead fish wrapped in butcher paper. Oh no, Arlette. Mayor Spaces, I visited the Central Florida Zoo today. Very cool. Mayor Space. It'll likely be months before any of you see any of those birds. Still haven't even gotten to the Toledo Zoo birds from August. I appreciate you doling those out patiently, Mayor of Space. It's good. Yeah. Anyway, everybody, I was thinking about sharing some distressing news about science programs being cut by the federal government right now under the Trump administration, and something like it's over 100,000 scientists and engineers who have just recently been laid off, and we're going to go over that, but I'm feeling lousy enough as it is right now that we might cover that another time. And we might just get into some fossil news here. Particularly because I don't really have a plan of action yet. I don't have anything that I can say, hey, go do this or go do that to help out. I don't want to be all doom and gloom and not have some kind of plan of action, some kind of remedy, something that you can do to make the situation better. I don't have that yet. So we'll probably be covering that next week. But, yeah. So, Lenina, I'll see what I can come up with for what people can do to help. But yeah. And there you go, Ali J. Yeah, no, it is a problem. Like this, you know, neoliberal austerity kind of deal. It's like Reaganite, Thatcherite, like, just, you know, cut funding for public programs, and that way the wealthy get wealthier, and then they give us more money for our political campaigns. It's something that ultimately hurts everybody, including the wealthy at the end of the day. It's not like it actually makes them happier to have obscene levels of wealth. It just makes them more miserable. Anyway, we'll talk about this another time. We're going to get into some fossil news here. So, without further ado, fossil news commences now. All right. First off, we're going to start off with some titanosaurs, sauropods, these long-necked, plant-eating dinosaurs from Romania. There's a new paper that just came out about them. Titanosaurs are these sauropod dinosaurs. Many of them lived in the late Cretaceous period. So after a bunch of the other big long-necked plant-eating dinosaurs go extinct at the end of the Jurassic, titanosaurs survive that extinction event. And they diversify, they develop this huge range of different shapes and sizes. Some of the titanosaurs were not too much larger than maybe a big horse. And some of them grew to be potentially the largest animals that have ever walked our planet. Titanosaurs as a group are just really fascinating. They get just enormous, like absolutely bonkers huge. Like bigger than a blue whale big. Significantly longer than a blue whale, and like we talked about on World Whale Day, significantly heavier than a whale too, because unlike whales who are neutrally buoyant in the water, whales don't really have weight, they have mass. Anyway, these guys actually have to support their full body weight on dry land. And, yeah, it's pretty remarkable that they got this big. Titanosaurs. Or titanosaurs, as some people call them. Yeah. How much of that is air, though? A good amount, Wombat Hole, yeah. Yeah. Pneumatized skeletons, air sacs, and just all full of air, which is one of the reasons why they were able to get so tremendously large, as they were extraordinarily efficient about the way that they did that. The architecture of their skeletons is just a thing of beauty. Incredibly efficient. Oh, yeah. Oh, and I'm so sorry to hear that, Miss Caprico. The male owl on Hoot House livestream has passed away. I'm really sorry to hear that, Miss Caprico. That's some really sad news. Shoot. Do we know what happened to him? Here, let's check in and see. See if they got the camera on the horses today. I think it was natural causes. He passed in the box. Oh no. Yeah, maybe we'll go check in there later. Yeah. I really hope it isn't bird flu, but it is something that's really on the rise right now. And then that gets into all the other news too about all of these programs being flashed and dismantled. Research being cut. Response teams to things like bird flu being done away with. I don't know. Things are not looking good in the US right now. They're really, really not. They're gonna get worse before they get better. Anyhow. Oh, that's really sad. I'm sorry to hear that. Anywho. let's get into our fossil news. Like we were talking. I don't know if we actually have a press release for this yet, but I'm going to check real quick about our titanosaurs. Doesn't look like we have that yet, but we'll just take a look at the paper. So this is from the Journal of Systematic Paleontology. Revision of Romanian sauropod dinosaurs reveals high titanosaur diversity and body size disparity on the latest Cretaceous hot egg island, with implications for titanosaurian biogeography. Now that title is a mouthful. I get that. Let's break it down a little bit. So, Romania is a country in Eastern Europe. Sauropods are the long-necked plant-eating dinosaurs. And so this paper is looking at remains from different titanosaurs and trying to figure out how many of them are actually different species. What's going on there? Big ones, little ones, are they the same species? Are they different species? They're trying to get a handle on what the diversity is there. That makes sense? And Hot Egg Island is no longer an island, but it was during the Cretaceous. Let's go back to about 66 million years ago. You can also look at 90 million years ago, but in either case, Europe did not look like it does today. It was a series of islands and a shallow, warm sea. It's an archipelago, essentially. Sea level rises and falls at the end of the Cretaceous, so these islands are becoming more separated. When the sea level rises, and then sea level drops, and there's land bridges that form between these islands, and so this whole thing is really fascinating because the dinosaurs that live in this place, sometimes they're isolated, sometimes they can walk from island to island. We're just starting to get a handle on what's going on here with how that affects dinosaur evolution. Because in isolation, when two populations get separated, and there's no gene flow between them anymore, they can become different species. We call that allopatric speciation. That kind of evolution in isolation is how you can get all kinds of really weird, interesting species on remote islands. Because they get cut off and they evolve in a new direction and just become really interesting. Think of like the dodo would be a good example. This dove that landed there on the island of Mauritius, and over the course of like 7 million years, it got huge, lost the ability to fly, became a really efficient ground-walking herbivore, eating seeds and nuts and vegetation.
These are just some of the questions that people ask about dinosaurs.
Bezo1, thank you for the follow. Welcome to Paleontologizing. But yeah. And Squeal says, wait, a huge dinosaur evolved on an island? How odd. That's the thing, is that some of these titanosaurs that ended up on those small islands seem to have gotten much smaller. This is something that we call insular dwarfism. To find you a decent video to help explain this, but if I can't find one, we can go back to Dinosaur Planet. Yeah, let's try that. So here we go. This was a Discovery Channel documentary. Came out in, what year was this? I want to say it was like 2004, 2005, something like that. Maybe it was earlier. But I remember being really, really excited for this when I was a kid. But this is kind of a dramatization of this concept of insular dwarfism. It's, yeah. It's It's kind of inspired by Gulliver's Travels, but with a cast of dinosaur characters. Take a look. So he's living on the mainland. So he's cast away because his, coastal home was inundated by a tsunami. He gets washed out to sea on this log, and then he washes ashore on a strange island. So let's see if we can get to the part with the titanosaurs once he arrives on this island. There we go. So there's a... And Coco, beware. Exactly. Yeah, I'm sorry your message got flagged. The auto mod can be pretty aggressive about anything resembling a swear word. Pride ourselves on being an all ages broadcast here. But I appreciate your comment. And yeah, that's kind of the point of this, is like, here's this normal sized dromaeosaur. He gets washed onto this island where everybody has become ensmallened through what we call insular dwarfism. And yeah, it's a fascinating idea. There we go. Yeah, Magyarosaurus. There you go, Neverwinter, yeah. Yeah. Even though they're much smaller than he is, and he could easily eat them, he's like, oh, shoot, they're titanosaurs. I better get away. Just instinctual thing. Hmm. And a lot of those titanosaurs are really wide, Dr. Irrefutable, yeah. To the point where their femurs kind of bow out to the sides in order to accommodate this huge gut that they had. They're very wide animals. You look at somebody like maybe Saltosaurus. Is that the one I'm thinking of? Maybe not. Maybe Saltosaurus is not particularly wide, but a lot of these guys were. Just seen head on, they're very round. Barrel torsoed. Anywho. And aren't Magyarosaurus, despite their dwarf size, still bigger than Pyroraptor? Presumably, yeah. But they're not that much bigger. Here. Magyarosaurus. There we go. Yeah, so Pyroraptor still would have been a fairly small animal. Probably. We don't actually have a lot of good material from Pyroraptor. I think there's only one specimen known, so we don't have a good idea of what the size range is, and I'm presuming here that nobody's actually done histo on it, so we don't know whether the holotype specimen is mature or not. But Megarosaurus is, it's not a big critter, you know? It's about 3 times longer than a horse, but its torso is about horse-sized. Yeah. And Bundalosaurus is there a reason animals get round like that? Is it simply for fat storage? It's not fat storage. It's being able to have a huge gut. So having an enormous rib cage like that you can fit tremendous lengths of intestine in, big stomach, everything else, it allows these animals to more efficiently process their plant food. Plants are generally far more difficult to digest than, say, meat. It's less calorie dense. That's why, you know, if you're trying to watch your figure, you might eat salads rather than steaks. There's just, you gotta eat a lot more plant material to consume, you know, to take in the same amount of calories proportionally to, like, meat, you know? So, yeah. Yeah. I want to say we had a clip about that. Where was that? I'm forgetting now. But, anyway, suffice to say, having a really big, wide rib cage, that helps you process food as an herbivore much better. There's a lot more room in your gut to be able to get your money's worth out of those plants you ingest. You know? Yeah. Bondo says, like ungulates, is there any evidence large herbivorous dinosaurs had multiple stomachs? No. I don't think ungulates actually have multiple stomachs either. They have multiple chambered stomachs. But that whole thing about cows having 4 stomachs, I think is kind of a misnomer, a misapprehension. It's kind of a myth. Yeah. Washington State University, myth. Cattle have 4 stomachs. There's 4 chambers in the stomach, but it's not actually 4 stomachs. So anyway, this is an interesting ruminant thing. So ruminants are this group of, is it actually a taxonomic group? Browsing artiodactyls belonging to the suborder Ruminantia. Okay, yeah. So on our tree of life, let's see if we can pull up Ruminantia. They don't have that. Let's try Bovidae. We can find the bovids, and then we can just go up from there a little bit. Yeah. Dr. Irrefutable says, do we have any kind of info about the gut workings of sauropods? Not a lot. There we go. So ruminants, I think that's this group. It includes cervids, deer like moose or Eurasian elk, saiga, antelope, mule deer, bison, critters like that. I'm pretty sure this is Ruminantia right there. I think this is this same clade right here. Those are the ruminants. But anyway, yeah. Yeah, So, the only thing that I think we're starting to really understand about sauropod digestion is that they did not actually use gastroliths, stomach stones, as has often been claimed. Instead, they just had a tremendous gut that would help them.
Do you think dinosaurs are put together correctly? The bones. You're smart. What do you think?
Do a research on that, Oliver.
I never.
Sankofa, thank you for the follow. Welcome, welcome. It's good to have you here. Yeah. Excellent. Yeah. Was her four stomachs never troopers? Yeah, Bundle Here, I'll give you a link to that article, by the way, from Washington State University. Yeah. Alright, gastrolith, gastromyth. There you go, Germ. Yeah. Yeah. Yeah, there's an old idea that sauropods, these dinosaurs, that inside their guts they had all of these stones that they would swallow. That would kind of roll around in the gizzard. And basically chew their food for them inside their guts. Because these guys didn't have teeth that evolved for chewing. These dinosaurs did not chew. The long-necked plant-eating dinosaurs in general were not... They did not masticate their food. They did not chew it. Pull up a clip here. There's Camarasaurus right there. Hey, DM Wing. Welcome, welcome. And Moosey Fate, good to see you. Yeah. If this were about a month ago, I would show you a Camarasaurus skull that I had here in my office for many years, that I 3D printed. But I have donated that to the Children's Natural History Museum of Fremont, California. Here it is here. So it's now on display at the museum in Fremont. I'll 3D print another one at some point, because I still have the files for it. But, yeah. They've got these big teeth in the front that are... They're for cropping vegetation. They're for biting. They are not for chewing. They would be really lousy at chewing because they're kind of spoon-shaped. There's that skull. Yeah. Yep. So they probably didn't actually do this. This idea has really fallen out of favor recently. But this documentary is from 2001, which is what? That's like 7 or 8 years ago now, right? There we go. Yes. But they chew their food. Yep. Yep. So we were talking about this. We were talking about this on Monday, right? Or was it Tuesday? going over some fossil news about how the extinction of big plant-eating dinosaurs led to, tree canopies becoming much denser and thicker because you didn't have critters like this knocking over trees and clearing out the landscape. Once those big sauropod and big ornithopod dinosaurs are gone, and the ceratopsians too, once the big plant-eating dinosaurs got wiped out by that asteroid, suddenly forests go crazy, and you get these super dense, thick, dark forests, which in turn caused plants to evolve larger and larger fruits and seeds, and that may have actually opened up the door for the evolution of primates, who originally were frugivorous, it seems, fruit-eating. So we, as human beings, and all other primates, kind of owe our existence, it seems, to the extinction of dinosaurs like this. That directly led to our evolution. At least that's what the fossil record seems to show. Pretty cool. Anyway, also here in this documentary, who's that? It's Papa Jim. Yeah. There's Papa Jim, who we do fieldwork with during the summers. Yeah. Anywho, this is When Dinosaurs Roamed America. I'll give you a link to it. There we go. Naderfiend says, I heard that there is over a 3% chance that a huge asteroid might be coming for us in a couple decades. I think that was just downgraded today. To like 0.3% chance or something. But it was literally just today or yesterday. This stuff is out of date. Shoot. Anywho. And Gazaway says it's cool thinking of how different our species would be if different variables were different. Because we'd probably still be here, but maybe would have gone to a more herbivorous diet. Gazaway? Well, no, that's the thing, is that there's no reason to think that mammals would have ever gotten big if it hadn't been for the extinction of the non-bird dinosaurs. Yeah. There's Gould talking about this, old Stephen J. Gould.
Whatever the cause, the extinction 65 million years ago left a void. With the end of the dinosaurs came a new opportunity. Out of the hole left by the Holocaust came the little mammals.
Yep.
If you want to argue.
So mammals and dinosaurs have pretty much always coexisted, at least the mammalia form, like proto-mammals, what we call stem mammals. They always existed alongside dinosaurs. They both show up in the Triassic period, both of these groups, mammals and dinosaurs, and they coexisted for a long, long time. So both of these groups, the dinosaurs and the mammals, evolved during the Triassic period. Dinosaurs probably about 240 million years ago, give or take. And the first true mammals probably evolved sometime in the Upper Triassic. Sometimes you'll see estimates that put it as late as the Lower Jurassic, but I suspect they were probably around a little bit earlier. They just tend to be extraordinarily rare, small things. The fossil record for early mammals is notoriously poor. But anyway, so both mammals and dinosaurs evolve in the Triassic, and they coexist during the Jurassic and Cretaceous periods. And this whole time, mammals were small. The very biggest, most gargantuan mammal during the entire Mesozoic era, for like over 150 million years, the biggest mammal that evolved is maybe about the size of a raccoon. Maybe a big raccoon, but like raccoon sized. Whereas, of course, you had dinosaurs that were, you know, bigger than whales. So yeah, when that asteroid hit, that was the mammal's big break.
Whatever the cause, the extinction 65 million years ago left a void. With the end of the dinosaurs came a new opportunity. Out of the hole left by the Holocaust came the little mammals.
If you want to argue, it's plausible that mammals got through and dinosaurs didn't, because mammals were small and smallness conveys advantages. They weren't small because they knew a mass extinction was coming. Presumably they were small for negative reasons, because dinosaurs dominated the environments of large-bodied creatures.
Yep. It's not quite the clip that I was looking for. Yeah, I gotta bookmark this one. There we go.
According to Stephen Jay Gould.
And it's therefore likely that we're here today because, by the luck of the draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction for which no creature could prevail or prepare. No, some scientists say that. Got killed in a mass extinction for which no creature could possibly prepare. And again, that gives the history of life its very quirky, fortuitous, chancy character. We are literally here only because of the good fortune of dinosaur extinction.
And I don't see any reason to argue with that. There's nothing inevitable about certain groups rising to prominence or anything. You get these freak cataclysms that occur on our planet, whether it's an asteroid impact or massive volcanic eruptions that cause runaway global warming and acidification of the oceans. You can get carbon being taken out of the atmosphere that causes an ice house Earth, where you get glaciers covering just about every surface on the planet. There's a lot that can happen. We wouldn't know this. We would have no idea about any of this stuff if it weren't for fossil science. If it weren't for the study of the history of life on Earth, we wouldn't know anything at all about this. If we weren't studying the fossil record and trying to learn about the history of life on our planet. That's why this sort of thing is so important, because if we as human beings want to survive and want to keep from getting destroyed by an incoming asteroid or destroying ourselves, which I think is far more likely, we need to have context. We need to know what's happened in the past. We need to know what to avoid. Because the history of life is full of all of these evolutionary experiments and different variables being thrown into the mix that throw everything off kilter. We have record of that stuff in the rocks. We can study it. We can see what's happened before. If we're intelligent about things, if we're wise, we might be able to learn from all those past events. Protect ourselves. Anyhow, I have neither context nor perspective without fossil science. Exactly, Golganak. Exactly. Yeah. Digital Deck, hello to you. Welcome, welcome. Yeah. And Makeaway says, I think we're fine on asteroids impacts now. We got the tech, but then again, that means, yes, we can destroy ourselves with it more likely. I'm not convinced that anybody's got the Sure, the tech might exist in a more or less theoretical sense, but is there the will to use it and to use it properly? You know, I've been thinking about that movie Don't Look Up an awful lot lately. You know the one? It's on Netflix a few years back. It's billed as a comedy, but it really is kind of terrifying because it's meant to be an allegory for poor handling of climate change. But they use an asteroid. An incoming asteroid is kind of a stand-in for that. And I don't know. It's a little too close to home, a little bit too true to life. It's, I think, a deeply scary film. But yeah. But yeah. And Petrodactylus, it's a zillion times better than Idiocracy. I think Idiocracy is a deeply stupid movie. I don't know. I've never liked that film. I don't think that it's... I don't know. It's got, like, pretty overt eugenicist... I was gonna say undertones, but they're just tones. Overtones, even. I don't know. I think Idiocracy is garbage. But Don't Look Up, I think, that hits really close to home. Anywho, yeah. Comedy that makes you feel true existential dread. Yeah, in the vein of, like, Dr. Strangelove or something like that. It really is kind of the Dr. Strangelove of our time. Yeah.
A real mean kid.
Ravenvolk,
6-inch daggers for
thanks for the follow.
He was the terror of his neighborhood.
Welcome to Paleontologizing. It's good to have you here. Yeah. But yeah. And Pickle Liquor says, we humans destabilize Earth, exterminate some species, but Mother Nature will still prevail. I mean, yeah, life on Earth is resilient. 90% of species can get wiped out, but give it a few tens of millions of years and things bounce back. Doesn't mean we will, though, as humans. We could very, very easily wipe ourselves out and wipe out all of these other lineages of organisms that have existed on our planet for hundreds of millions of years. You know? There's no sense in, doing a biodiversity murder-suicide. There's no reason we should do that. But that's the direction we're heading in right now, unfortunately. But yeah. Anyhow. And failsafe. Yeah, wasn't that a book? Especially about? Yeah. Anywho. Slim Pickens, Rodeo Squid, a weird adult, yeah. And Native Fiend wants to know, is high intelligence always going to be the end game of certain lineages? We don't know. That experiment's never been run. It's happening now, but we don't know how it's going to end. So no, I don't think there's anything inevitable about that. We've got a choice right now. Humanity is kind of at a crossroads, but we have been for a while, and we will continue to be there for a while. But, I don't know, in the present, it seems really stark. We've got a choice. Do we want a Star Trek future? Or do we want a Mad Max future? decisions being made during this decade very well might determine which direction we go in. Do we want a future where people work in cooperation with one another? They use technology for good? They put science and empathy and kindness at the forefront? We try and solve problems here on Earth? And maybe go explore space too, if we can get there? Or do we want to fight? Do we want to let malice and greed rule over us? Do we want to bring on a man-made apocalypse that'll eventually destroy all of us? I know the future I want. But yeah. Yeah, anyway, sorry, we're getting way off topic here. Who do we think we are? Let's get back to a group of organisms which were incredibly successful for tens of millions of years and then disappeared completely. Titanosaurs. Worried about overarching plutocracy too, Robert? I agree. That's what would take us to a Mad Max future. Yes. But yeah. Yeah. Titanosaurs. A review of titanosaur fossils from Romania. Let's take a look at the paper here, and it is open access. Here's a link, if you'd like to read it. No paywall here.
Access granted.
Revision of Romanian sauropod dinosaurs reveals high titanosaur diversity. Got a bunch of different kinds of titanosaur from the late Cretaceous Romania, according to this paper. And body size disparity on the latest Cretaceous Hateg Island, with implications for titanosaurian biogeography. So again, anybody who just kind of waltzed in recently, if we look at Earth about 90 million years ago, up until about, well, let's say 66 million years ago, sea levels were higher back then. Europe was a series of islands, kind of an archipelago in sort of a warm, semi-tropical sea, like this. And so on different islands, different organisms started to evolve in interesting directions. Evolution and isolation. I'm rehashing what we were talking about earlier. Some of these titanosaurs, these enormous, just gargantuan dinosaurs, some of the biggest things that ever walked the earth, some of them end up on these islands and they significantly ensmallen. And something we call insular dwarfism. And that's part of what this paper is going to explore. So the Hateg Basin and surrounding areas in Transylvania, western Romania, have been a hotspot for research on vertebrate faunas, so that's different animals with backbones, they're fossils, of the late Cretaceous European archipelago. Again, this series of islands from the late Cretaceous. One of the historically earliest titanosaurian sauropod dinosaurs to be discovered, the dwarfed species Magyarosaurus. So this is a titanosaur that is not titanic. It's actually really small for a sauropod dinosaur. It would be big compared to most of the mammals walking around today, but it's not a large creature. Yeah. Very, very, very small for a sauropod. The dwarfed species Magyarosaurus dacus comes from the lower Maastrichtian deposits in this basin. However, this species has been neglected, with no modern treatment of its anatomy, taxonomy, or phylogenetic affinities. So it's not been well studied over the past decades. This critter has kind of sort of been ignored for a while. Yeah. Via detailed anatomical study of historical and undescribed remains, so by actually studying some of these fossils in depth for the first time, combined with archival data, we identify shared autapomorphies that link multiple partial skeletons. So they're able to actually link up, like, hey, we've got some missing pieces from this specimen, let's see if we can find them in this specimen over here, and they've been able to kind of fill in some of those gaps there. Our analysis of hundreds of specimens, including more than 20 monospecific assemblages. Monospecific assemblages where you've got a bunch of the same species all in one place. Enables the stabilization of the type species of Magyarosaurus dacus. So they can actually figure out what does this animal look like. They've got a good sense for what its anatomy is and how to tell it apart from other sauropod dinosaurs, essentially. So we propose the presence of 3 additional, but only partly contemporaneous taxa. So they're saying, we've got Magyarosaurus kind of figured out now. But in doing that, there's 3 kind of weird outliers. Things that very well might be different species than Magyarosaurus. And they lived, some of them lived at roughly the same time. Polluted Titan, Nalatzensis, Petrus Titan, which was previously Magyarosaurus hungaricus, and a new genus, Uriash cadisi, new genus and new species. The latter being amongst the largest known sauropods of the late Cretaceous European archipelago. They're actually naming a new dinosaur in this paper. I didn't realize that because I haven't read this until right now. So yeah. We present a new phylogenetic analysis. So they've come up with a new family tree here. 152 taxa, so that's 152 different species, scored for 570 characters. So they're looking at different aspects of the anatomy, different measurements, different features that they're able to pick out. They've got 570 different features they can plug into a computer model, and it'll yield a family tree based on how similar these features are in these different dinosaurs. With implications for broader titanosaurian evolutionary relationships and biogeography. So it can tell us a lot about which titanosaurs are living where at what times, and what that says about their biology, essentially. And how they're related to one another. So Magyarosaurus is recovered either as a member or a close relative of Saltasauridae. Interesting. So they're saying Magyarosaurus seems pretty similar to this guy. Good old Saltasaurus.
Work of vertebrate paleontologists.
Tofurobots, thank you for the follow. Welcome. It's good to have you here. Yeah. So Saltasaurus is known for having these osteoderms, these armor plates on its back. There's an old reconstruction of it there. That's charming. Yeah. Here's a model that you can get from Safari Limited of Saltasaurus. It's a neat critter. Kind of your classic armored sauropod. So Magyarosaurus, this little guy, comes out in the analysis as being a close relative of Saltasaurus. These guys are allied. They're part of the same, little family. Which is not surprising, I guess. You often see depictions of Magyarosaurus looking just like a miniature Saltasaurus. So this is not shocking. Polluted Titan has affinities with Lognocosauria. This has always been difficult to pronounce. Lognko. Lognocosauria. Loncosauria. I'll say Loncosauria. Along with the contemporaneous Lahueco Titan. Petrus Titan is most closely related to South American early diverging Eutitanosaurian taxa. And Uriash, our brand new dinosaur just named in this paper, also shares affinities with Gondwanan taxa. So they're saying that these dinosaurs here from the European archipelago in the late Cretaceous look similar to the dinosaurs in Africa, in Australia, and Antarctica to a certain extent, but especially to South America, which is interesting. These guys up here in the north look so similar to these guys down in the south. Often you have the dinosaurs in North America and Asia looking very, very different than the dinosaurs in the southern continents, we call Gondwana. Go back a little bit to, say, 120 million years ago. Gondwana are the southern continents. That's South America, Africa, India, and Madagascar. Antarctica and Australia and New Zealand. This is all Gondwana down here. When you think Gondwana, think south. Up north, you've got Laurasia. That's a combination of North America, Asia, and Europe. The northern continents, Eurasia. Does that make sense? We'll be returning to this concept again and again today as we go over some of these other papers too, because it will come up again. Oh yeah. Yeah. But yeah. And Yuriash means giant. Thank you, Nedbug. Interesting. Is that Hungarian or Romanian? Huh. Good stuff. So let me finish up the abstract here, and then I'll get into questions. Our findings strengthen the hypothesis that the latest Cretaceous European titanosaurs belong to Gondwanan lineages. So these guys from up here in Europe evolved from titanosaurs that are from down south in Gondwana. They somehow made it up north. They somehow made their way up there, and there they are at the end of the Cretaceous. Their origins are in Gondwana, the southern continent. So our findings strengthen the hypothesis that the latest Cretaceous European titanosaurs belong to Gondwanan lineages from down south, then invaded the former area up north during the Barremian to Albian stages of the Cretaceous. So we interpret the presence of body size disparity as either evidence that large-bodied taxa were ecologically excluded from body size reduction by competition with small-bodied titanosaurs, or that dwarfing occurred stratigraphically earlier among several lineages, and the small-bodied titanosaurs on Hattic Island are the descendants of existing dwarfed ancestors. Interesting. So they're trying to figure out, when did some of these guys become small like this? And there's two kind of options that present themselves. Either they evolved from earlier dwarfed sauropods, or I guess it's just easier for these guys to get small when they arrive on these islands. And then maybe you've got further migrations of titanosaurs that start off big, and they don't get small because these guys are already taking up the small-bodied niches. So the big guys are like, I guess we stay big. Maybe we just don't become as plentiful as the small guys because there's limited resources on
ontogeny.
Interesting stuff. Finally, we find no indication of a body size related titanosaurian turnover in the uppermost Cretaceous of the Transylvania area. Body size related titanosaurian turnover. I'm not totally sure what they mean by that. A turnover event in evolution is when you get a group of critters, group of organisms that go extinct and they get replaced by new organisms. Whether the introduction of the new organisms drives the old guys into extinction, whether that causes the turnover, or whether there's another cause that drives them into extinction, and then the new guys migrate into that void filled later. Turnover doesn't really necessarily imply either one. It could be either. But yeah. And Blame Me for That Loss says, how would they know if they're their own ontogeny or dwarf versions of titanosaurs? You do that by cutting the bones open and looking at the growth rings. So by doing histology. So you can tell if a dinosaur was young, and that's why it was small, or whether it's just an adult, full-grown adult of a small species. You can tell by cutting open those bones and looking at the growth rings to figure out, is this critter done growing and it's just a small species? Or is it still growing and the reason it's small is because it died when it was young? That's how we figure that out. That's how we actually test that idea. It's by doing histology. And hopefully there's some discussion of that in this paper. Histology is one of those essential methods in dinosaur paleontology. If you're making big claims about new species that are smaller, and it's a new species because it's small and all that, and you're not doing histology, you're not testing that idea, you're probably not doing things right. It doesn't seem like the word histology shows up in this paper. Okay, it shows up once in the entire paper. Finally, osteohistological research targeting the Romanian titanosaurs has also hinted at the presence of at least one other large-sized taxon in the faunal assemblage besides the small-bodied Magyarosaurus and Paludotype. Huh. I would like to have seen more discussion of histology in a paper like this. That's not super encouraging. And it's not like this is a short paper, so they didn't get to it. This is... This is a very long paper. Holy cow. 126 pages. Yeah. So yeah, that's not super encouraging. Again, the only real way to tell if a dinosaur is full grown or not is to do histology. That's the only smoking gun you can get. The only bit of, like, real, inarguable evidence that an animal is full grown is if you look at the growth rings in the bones and it's clear that this animal has stopped growing. It's fully mature. So yeah. Huh. So you asked an excellent question there, Blame, and I appreciate you for it. Yeah. And Community Time says, have to head out, but this was a great stream. I look forward to hanging out and hear more. Yeah, thank you, Community Time. I really appreciate you. Thank you for subscribing. Thank you for supporting Science Outreach here on Twitch. Have an excellent rest of your day. Thank you. Yeah. And PC Snowart says, is histology super cost prohibitive or something? Why do so many not have it done, it seems? It is it's not super costly, but a lot of people see it as, like, destructive. Because you are cutting the bones open. But, yeah. I mean, we don't collect dinosaur fossils because they're pretty. We collect them to learn about the history of life on Earth. And if you have rules in place that forbid you from running these tests and gathering the data that you can only get from these tests, then that's... Like, are you really doing real science in the way that you should be? Here's, you could call her the queen of dinosaur histology. This is Holly Woodward Ballard kind of explaining this process here.
I was wondering if someone was going to be concerned that I was actually cutting a bone. So this is a Maiasaura, a duckbill dinosaur humerus.
It's the upper arm bone.
So one of my graduate students is trying to figure out how the forearm of Maiasaur was growing.
It's actually this one. That's the left forearm.
He's done some histology on
or
this,
left upper arm.
The really cool thing is when you remove a piece of bone, you can make a mold and cast of that piece, which replicates the original in every way, every detail, and then you can reinsert that piece back into the bone.
So what she means here, I don't know if you caught that. Holly is saying that, like, in order to be able to do histology, you have to take a chunk out of the bone. So you take a rock saw or something and you cut out a section. And then you can take that section, before you do anything else, you make an exact copy of that section. So it's exactly the same as the original in its shape and everything. And then you put that in the gap where it came out of, and you glue it and you paint it so it looks exactly like it did before you cut it. And yet you've still got a chunk outside of the bone that you can run your tests on. Does that make sense? Yeah.
More recently, we have even more high-tech options like 3D scanning, which digitizes the specimen and the piece that you can take out. So you have a complete digital record of the bone. Some museums ask that we paint the cast and then reinsert it. So in this bone, this middle piece right here is the cast piece. So you can see
the
how
replica piece
it looks
in the middle.
really nice, just continuous. The only reason you could suspect it was a replica is just the two little cut lines there, but otherwise it fits back into the bone perfectly.
And so it looks just like the original, and yet you've got this piece you've taken out that you can do really important science on. Again, that's why we collect these fossils in the first place, is to do science on them, you know?
So that's my first pitch for why you should let me do this. And the other reason is that we would have no idea about these dinosaurs, how old they were, sometimes if they were male or female, their growth rates, their growth curves, if we didn't look inside the bone.
Yep. So Jack actually has this will make sense in a second. There we go. So we're going to use dinosaur eggs as kind of an analogy here too. The same thing applies to histology, collecting data. This is all the same idea. We're just approaching it with a different kind of specimen.
And I don't know, there's something about dinosaur eggs. Maybe you can explain. We'll have a non-dyslexic conversation after this, all right?
So Jack famously is dyslexic. This is my old boss. He ran Museum of the Rockies. He ran the paleontology program there when I was being trained as a paleontologist at Museum of the Rockies. And he was also Holly Woodward Ballard's doctoral advisor. So Holly was Jack's PhD student. So you can see where, you know, he's kind of passed this philosophy down to her and to everybody else who worked for him, basically.
Dinosaur eggs actually had been found in the 1800s. And so dinosaur eggs had been found in the 1800s. They'd been found in France. They'd been found and then in the 1920s, they were found in Mongolia, and some were found in China. And I've started finding these eggs in the 1980s, and I was the first person to find a dinosaur embryo.
Yep.
A little skeleton of a dinosaur inside the egg. Now, here's our dyslexic question. Dinosaur eggs were found in the 1800s. The first dinosaur embryo was found in 1983. What advantage did I have over everyone else in the world for all those years?
What advantage did Jack have? How did he end up finding the first dinosaur embryo ever? What special advantage or What leg up did he have that nobody else had?
That means then that dinosaurs really did not become extinct.
Hang on.
That we have their descendants around.
Patrick Pirate.
I think that's fantastic.
View.
Sort of Patrick Pirate. Yeah, thank you for the 49 months of support. I really appreciate you, Patch. I hope you're doing well. It's good to see you. Thanks for your support. So what did Jack have?
Found in 1983. What advantage did I have over everyone else in the world for all those years? I had a hammer. That's all there was. I had a hammer.
Yep.
For all of those years, people had... Now, see, this is the problem with reading.
So this is the talk that Jack gives about dyslexia and how, dyslexia, Jack is very dyslexic, it can provide a lot of challenges, but there's certain advantages, too, that dyslexia can give you, and that kind of makes you think differently than the people around you. Gives you a different perspective. This is why it's so important to have so many different kinds of people to work with. Different kinds of people in your laboratory, different kinds of people at your job site, people with different ideas, different perspectives, different backgrounds, different experiences, because you never know when somebody's going to have an idea that just revolutionizes your field or helps you solve a problem that's been bedeviling everybody for a long time. Having a huge variety of different experiences, different people, it's essential,
Reading is really overrated if you think about it. People had convinced one another that they shouldn't break eggs open because eggs are precious. And so no one ever broke an egg open. A dinosaur egg. I even went to museums and I said, "Can I just break one of your eggs open?" And they said, "No, you can't break your eggs because they're precious." And I said, it's just like having a present that you never open because it's so pretty. Seriously, no one had ever found a dinosaur embryo. So I've gone back now that people saw that I could break them open, and glue is cheap. You can just glue them back together.
Yep. Glue is cheap.
There's nothing that you can see. You can see in my picture there.
Glue is cheap.
The thing's actually held together with a rubber band. After you break it, you just rubber band it back together again. Anyway,
glue is cheap.
That's so then.
So this same attitude doesn't just apply to dinosaur eggs, like dinosaur fossils in general. If we want to actually understand these as living animals, not just as a curiosity, not just as a pretty object, but we want to actually understand the biology of these animals, you sometimes have to do what some people might call destructive sampling. We would call it enhanced sampling at Museum of the Rockies. That was our term of art that we used. But yeah.
And I've been really lucky in getting to do this. Before I went to Australia, only one polar dinosaur from Australia had ever been histologically sectioned before, and I increased that sample to 12. So that doesn't sound like much, but for paleontology, that's a nice sample.
It really is.
And then more recently, I've been looking at T-Rex. So I do have a prop here of, this is a slide of a juvenile T-Rex.
I think that's Jade.
Tibia.
Yeah.
All the brown is bone. And it started out as a block. So I take the bone, I embed it in a plastic resin. And then I take a thin slice out of that resin. The resin is basically there to keep the bone from crumbling. Then you glue it to a glass slide, you polish it down, and then it's so thin that light can pass through. You can put it on the microscope, and the picture I have up on the monitor behind me is actually a piece of dinosaur bone.
So there's polarized light that's shown through it in order to get those like color differences and help you really pick out the lines of arrested growth, the growth lines in the bone.
So that's the process, and I've been able to do it and all kinds of cool stuff, including, this is one of my favorites. This is a slice from a T-Rex femur. So I'm histologizing, I guess you could say.
I think this is the same Tyrannosaurus femur that we saw in North Dakota, by the way. I think that's probably... Probably this one.
Juvitrike 3 because it was the third Juvitrike I found that year. I think I found like 7 in total at some point. They weren't all. This is the best one by a long way, but Little Naughty Devil's pretty good too. I didn't name it.
Oh, it's named after.
Build part of it.
Here, was it this day or the day before? Let's check the transcript real quick. Do a Control F for femur. But I'm pretty sure this is the same Tyrannosaurus femur. No, it was the day before.
Okay, that's
this is when we went back into the lab and into the collection space. Let me find that, because I know we talked about it. I'm pretty sure this is the same Tyrannosaurus femur that Holly was sampling there, so the same one that we saw in that video. This one doesn't have search.
Glue is cheap.
There we go.
Right. Really need to completely cut things with, and it's one.
There it is. There,
It's
yes.
a little bit bigger than.
Line shot, so there should be links to that in the chat if you use the commands.
Guess we'll talk about that tomorrow.
Yeah.
This is birth of the Tyrannosaurus Rex. It's one of the biggest T-Rex. It's only a leg, but it's very similar in size to Sue. I'm told it's a little bit bigger than Scotty, but not quite as big as Sue. Some people think Scotty is bigger than Sue.
Yeah.
I don't know, because I don't really do Tyrannosaurs, but some people are very excited about this specimen.
Don't have a horse in that fight.
It's not very well reconstructed, but it's from North Dakota, and it's one of the biggest T-Rexes known. And the important thing about it is, we've cut all 3 of the bones, so we have a really good growth record of this animal. And they didn't do that for the other really big ones.
Right.
So this is one of the only big T-Rex for which we have a complete growth record.
Nice.
Which obviously is important when you're big, because did
Yeah.
you get big through growing fast? Did you live a long time with a different growth speeds at different times? There's lots of different things that we can get from that growth record. And to do that, you really need to completely cut through the bone. Just a little core isn't going to cut it. Isn't going to do it. You really need to cut completely through.
So you've got that from the femur, the tib, and the fibula too?
Yeah.
Wow.
The fibula actually isn't any use. But so we cut it to compare the fibula with the tibia and the femur.
Right. Yeah, usually a fibula has got
one of the things that
too much remodeling. So like all of the growth rings on the inside of the fibula, they tend to get kind of morphed and squished, and they're just kind of useless. The fibula has become too remodeled. There's been too much remodeling of it over the course of the animal's lifetime, but the tibia is usually the best bone for dinosaur histology. I'm not sure exactly why. I guess it has the least amount of remodeling. There's high fidelity there for all of those growth rings. They don't change or get too messed up during the animal's lifetime.
Let's
Marcy
go.
Walks Dogs. Thank you for the 8 months of support. I really appreciate that, Prime. Thank you, Marcy Walks Dogs. Appreciate you. Yeah.
We're not doing that research. It's being done by Holly Woodward down in Oklahoma.
Yeah.
And she says that, the fibula basically doesn't have the full growth record, or it's not as consistent as the tibia, and in this case, in theropods, the femur. So that's just something to confirm.
Yeah. So Holly Woodward, like you mentioned there, here she is, and there is that segment that was taken out of that femur. This same one right here. See, as you can see, I was actually trying to find the cuts on this. I think it was not while I was streaming, but trying to find where this section got taken out, I couldn't find it. It's been, because they made a cast of it, and they put it right back in. They filled up that gap, and they painted it, and you can't even tell where that section was taken out. But here's Holly holding it right here.
New word. This big T-Rex femur, so that's so cool.
How I want to get back to T-Rex in a moment, but how do you even grind a slide that's that big?
So for something like
UV
this,
light, that would do it,
I
Murph.
actually
Yeah.
have to cut it down into pieces, but I measure the thickness of each cut so that I know how much I'm taking away every time I make a cut, so that I can reconstruct this digitally, and I end up with like a 12 gigabyte file, but it's this T-Rex stitched back together. Sometimes my computers have a lot of trouble with that. But that's I have to do it.
My colleague Carrie Levitt-Busion, who also works here, sympathizes with you about that exact problem.
Yep.
Well, since you brought up T-Rex and showed us some amazing slides and samples from it, we actually had a question from a viewer on YouTube who wanted to know if histology could help solve this problem of whether things are juvenile Tyrannosaurus rexes versus maybe another species like Nanotyrannus.
Oh yeah, so histology.
So Holly actually worked on this. The Jane specimen, which has been touted as a Nanotyrannus, Holly cut it, and she's like, "Oh, the thing's a juvenile. It's not full grown."
Is one of the ways that we can independently test that hypothesis, and is something that my team actually did last January. We did histological sections of small tyrannosaurs, which, you know, some people say are juveniles and some people say are Nanotyrannus. And we looked at their histology, and we compared the histology to what we see in modern animals. And the histology of these small tyrannosaurs matched more closely with animals that are still growing. They have juvenile tissues compared to what we see in something that's an adult. So our inference from that is that the histology supports that these are juvenile animals. They could be juveniles of something completely different, but right now the only other tyrannosaur we know of in the Hell Creek is T-Rex. So it makes most sense to say it's a T-Rex until someone can show otherwise.
Yeah. Really, really cool talk here. Cool interview with Holly Woodward-Ballard there. There's a link in the chat for you. It's good stuff. So anyway, the point is histology, cutting these bones open and counting the growth rings to figure out if they're young or old, is essential stuff. Shoot, if I was like chief editor at one of these scientific journals in which new dinosaurs get published in, I would probably have that be like a requirement. If you want to name a new species, there should be histology on it. You should know if the thing is fully mature or whether it's just a juvenile. There have been a lot of different dinosaurs that have been named that weren't actually new. They're just juveniles of previously known genera or species. So yeah, that's important, and I wish there were more histology in this paper. Again, I haven't read the whole thing, but yeah. And I realize this paper isn't really about histology necessarily, it's just trying to make sense of these titanosaurs, but histology is an excellent tool for that kind of thing, and it would be nice to see more of that in here. So anyway, yeah, I hope that makes sense. Here's a link to the paper, by the way, if you want to read it yourself. Revision of Romanian sauropod dinosaurs. They're saying, shoot, there are a bunch of different titanosaurs living in the same place roughly the same time. I would be much more confident in accepting that conclusion if they'd done a lot of histo and really demonstrated that the differences they have in size is because of... those are phylogenetic differences rather than ontogenetic differences. But a lot of folks are hesitant to actually cut the bones open. I know it's extra work. I know it's destructive sampling. It's not really destructive. We're using fossils to figure out the biology of these animals. That's why we dig the fossils up in the first place. So yeah, I don't know. I've got strong opinions about this, and I hope it makes sense at least, even if you disagree. And Pimpcat says, being that Jack Horner consulted on the Jurassic Park movies, do you know if he suggested they put feathers on the velociraptors? He did. I've heard him say this in person. That Jack really wanted there to be feathers on the dromaeosaurs, on the velociraptor. He really fought for them being bird-like. Let's see if I can find a clip. I don't think he mentions feathers here. But... there we go.
Of each dinosaur, and to weave in information now that was coming out about dinosaurs to try to make these as accurate as possible.
And look at the half-moon-shaped bones on the wrist. It's no wonder these guys learn how to fly.
Well, the first person we went to was Jack Horner, not just to achieve an authenticity, but we wanted a credible resource that could back up several theories that we were sort of expounding. And one was that dinosaurs eventually evolved into birds.
And even the word raptor means bird of prey.
And that's something that Jack Horner believes in and could defend if necessary. And Jack Horner became our credibility.
Then we started working on maquettes, and
yeah, Jack had not as much input as he would have liked. Not as much input as I would have liked him to have either. Other dinosaur paleontologists, I think, feel the same way. Yeah, but the, is it here? I'm trying to find the documentary where they mentioned the tongues. It might be here. Nope, it's not in this one.
Spectacular.
We'll try this one, and that'll be our last try. And we'll move on. And searching the transcript here. No. That's okay. Originally the velociraptors, the Deinonychus, the dromaeosaurs, were supposed to have these snaky tongues. There we go. Yeah, so this is a stop motion kind of what they call an animatic, so like an animated storyboard. And see, there's this tongue flicking out like that. And so originally that's what Spielberg wanted. And apparently Jack was furious about this. He's like, you can't do that. You're going to confuse audiences. You're going to introduce this idea that these dinosaurs are really lizard-like, snake-like. That's the idea. We're trying to avoid that. What are you thinking? And I don't know. It might be apocryphal, but I've heard that Jack threatened to quit over that. And Spielberg's like, okay, shoot. Oh, I remember now. It was Phil Tippett. He was talking about this in a documentary. Here, I don't remember exactly. Is it in here, maybe? Let's see. I get worked up about this sort of thing because it. Man, we do not have a long transcript for this. That's lousy. I'm not sure I'm going to be able to find you this clip. This is why I like to have a big backlog. With stuff all tagged with keywords and everything.
So when Jurassic was mounting, Spielberg talked to George, and George said, you should talk, Phil's your guy, he's a dinosaur guy.
Yeah, Jurassic Park was a really big deal, and so setting all of that up was quite an endeavor, because I knew enough about paleontological history and how they operated as animals and not as movie monsters. So I think that was very important for them.
So the animatics were done conventionally with like Barbie and Ken puppets and stop motion stuff. And initially on Jurassic Park, everything was intended to be done somewhat more conventionally between the full-scale live action.
Anyhow, yeah. Let's see. With the original trilogy, he just suggested that comes together. Yeah, 1993 or 1992, I guess, before Jurassic Park, the first one came out. Jack wanted there to be feathers on the dromaeosaurs. That's what I've heard. I've heard him say this years ago. Insifan says, quick glance over the paper shows more histology mentions. Is that right? Did it just not load properly? Here. Let's see. View PDF. It is a really long paper. Here, info panel. Can we do a search? There we go. Okay, wow. 19 matches. Let's see. They did do some more histo in here. Okay, excellent. The presence of a larger titanosaur is also supported by the osteohistological study of Stein et al. 2010. So it looks like they did actually put more thought into histology than I had feared. Good for them. Excellent. Taking all the archival, morphological, taphonomic, and osteohistological and geochemical evidence together, regarded as highly probable that this entire set of titanosaur remains came from a single spatio-temporally restricted fossil site. Oh, very cool. I still don't see any images of histo slides yet, but it looks like they're at least paying attention to what previous authors have said about histology. But here we go. For one of these critters, because no histological analyses have been carried out for Petrus titan specimens, it is currently unknown whether they belong to immature or adult individuals, and thus their attribution to a dwarf species must be treated with caution at present. Good. Okay, I'm glad they're talking about this stuff. Yeah. Nice. Alright, good stuff. Good stuff. Anyway, good. Well, I'll say they are partially redeemed. Partial save. There you go, Insafan. Yeah, thank you for piping up about that, by the way. I appreciate it. Thank you for your input. Anywho. Yeah. Yeah. And Mayor of Space, under a week, Amazon will no longer allow you to download your ebooks onto your PC. I don't have any ebooks through Amazon, but if anybody else does, take heed. Yeah. Huh. I've got a lot of audiobooks, but no ebooks. I've never liked ebook readers. I always found the interfaces really clunky and things felt proprietary file formats and stuff just always really turned me off. But yeah. Anywho, we've got some other fossil news to go over. And let's get to it. We'll talk about some of these Australian dinosaurs. And then we'll talk about the origin of feathers. So it's interesting. There seems to be two different press releases for the same paper here. I'm a little confused by this. But here on phys.org, I'm not 100% sure these are the same paper. I didn't really have time to really go over this in depth yet. But this is from today. Carnivorous dinosaurs thrived in Australia 120 million years ago, new fossils show. And then new Australian dinosaurs and the oldest megaraptorid fossils in the world. This is from yesterday. This press release is written by Museum Victoria. And this one by Jane Kotevsky and Stephen Poropat from The Conversation. So this was published in JVP. And this was published in JVP. We've got two different press releases for the same paper. I'll give you links to both. Right here. Another megaraptorid? Yes, indeed. Crimson Carnotaurus. They don't name it. And I'm grateful that they don't name it because it's very fragmentary. But yeah, good stuff. There's even a really spiffy video that goes with this that I will share with you right here. Very polished. Let's take a look.
This is the site where we've recently discovered the fossil remains of one of Australia's largest theropod dinosaurs to have ever lived. The fossil bones from this place belonged to what's known as a megaraptorid dinosaur. This is a two-legged, fast-moving predator.
So, what's interesting is that when I was a kid, back in the 90s, we had this announcement about Megaraptor. Like, oh, Deinonychus, Velociraptor, Utahraptor, Megaraptor. Megaraptor was first known from this big claw in South America, from Argentina. It's big. It's a big honkin' claw. This thing is huge. And so originally the idea was that this is the same like gigantic killing claw like you see in dromaeosaurs, like in Utahraptor, Deinonychus, and Velociraptor, etc. But, you know, it's enormous. So, oh, biggest dromaeosaur, it's huge. But the thing is, it doesn't look like a dromaeosaur sickle claw. And it turned out not to be. It turned out to be a hand claw of a new kind of dinosaur. Yeah.
6 to 7 meters long.
And we're on the forefront of Megaraptorid discovery. Right here where we're sitting is the deposit with the oldest Megaraptorid fossils in the world. And this is a type of theropod dinosaur which we would call a hands-first predator.
So unlike a dromaeosaur, they've got the big claws on the hind feet. These guys have got big muscular arms with enormous claws on the hands, including that big thumb claw like we just saw.
Got these large muscular forearms with these hypertrophied, big recurved claws, and they're effectively bringing you in for a hug of death. They're piercing you, they're grabbing you to consume you.
What we have discovered are the fossil bones of its lower leg and some of its vertebrae. We often only have partial or fragmentary remains to work with.
So not a lot from this animal. We got what? Distal tibia and 2 caudal vertebrae, neither of them 100% complete. So we've got less than 3 complete bones from this animal. So this is why they didn't name it. But they do know that from this, we're able to tell this looks to be a Megaraptoran dinosaur, a Megaraptorid. It's a member of this family because these parts, you know, compare positively with the same parts in other Megaraptorid dinosaurs. We've got other ones from Australia, things like Australovenator. Presumably this is from a different time, and so it's probably safe to say that it's a different dinosaur. Australovenator, I think, is from more recent in time. Paleoecology. From the Winton Formation. The Winton Formation is late Albian to early Turonian, so that is later on. I'll show you that. So in the Cretaceous period, the last period in the age of the dinosaurs, we've got a bunch of different stages over here. So the Megaraptorid, the fragmentary one you're seeing in that video, the new guy, is from like the early Aptian, it seems. Whereas our other guy was what? Albian to Cenomanian? Is that what it was? The Winton Formation, Australovenator, late Albian to early Turonian. So late Albian to early Turonian. We don't know exactly how old those rocks are, but they're within this window, it seems. Whereas our new guy is from earlier in time. So it's not going to be the same dinosaur. It can't be if it's a different age. You know, dinosaurs are constantly evolving and changing. They do not stay the same.
With
the bits that attach together, the articulation points, are very informative with fossils, and particularly in theropod dinosaurs. So even though all we have is the bottom of the tibia, we can see features that are shared within a group. But the vertebrae we found, the part of the tail that they come from, unseen in Megaraptorids.
Which is kind of crazy. This group of dinosaurs, Megaraptorids.
From prehistoric time.
Thank you, Remedino, for the follow. Welcome to Paleontologizing. Megaraptoridae. Well, here we go. This is a group of theropod dinosaurs that are really only known from the southern hemisphere, from Gondwana, like we were talking about. But the most complete Megaraptorids tend not to be super complete at all. This is still a mysterious group. We don't have every bone from the skeleton represented yet. So even if you were to take all of the bones from every Megaraptorid that has been discovered, every different species, stick them all together, you still wouldn't have a complete skeleton. This is still kind of a mysterious group of animals. We're still figuring them out. So here, where they've just got 2 caudal vertebrae, 2 vertebrae from the tail, and then the distal end of a tibia, the shin bone, even with such a small sample size, these vertebrae are still new for the entire family. Nobody else has got these vertebrae represented. So even with such scanty remains, this is still new and important, which is kind of wild to think about, you know? Shoot.
And the part of the tail that they come from, unseen in Megaraptorids.
Nuts, you know?
Every fossil we find adds a piece to the story. We have recent research that showed the large theropod footprints of about 40 centimeters, and they estimated that.
So you see that right there? You've got middle toe right here. That looks like it's probably the inner toe. So this is probably the left foot. And then you got the outer toe right there. So the little hallux would be here. So digit 1, digit 2, digit 3, digit 4. Digit 1 wouldn't have left a mark.
To be about a 1.8, 1.9 meter tall at the hip animal.
There you go.
That's this.
Yeah. Coffee Sells Books. Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Raymond Dino says, "Whoa, that one has feathers." These animals may have been feathered. We don't really know. We don't know much about Megaraptorids yet. Were they feathered like some other meat-eating dinosaurs? Like you see here, kind of shaggy feathers? Or did they have scaly skin? We don't know yet. Yeah. And Insafan says, "Wait, how did you see that?" What do you mean? It's right here. So there's the outline right there. So there's one toe. There's the other toe. There's the other one. He's kind of pointing to it.
That to be about a 1.8, 1.9 meter tall at the hip animal. That's this Megaraptorid. That's this theropod. That is getting to 6-7 meters in length.
In fact, actually, I think the lines put in post right here are not quite right. But
hip animal.
Yeah.
That's this Megaraptorid. That's this theropod.
Nerduino says, "What advances would be needed to determine if they were feathered or not?" Fossil feathers or fossil skin. So far, this group is so poorly known, the Megaraptorids, that we don't even know what the whole skeleton looks like. So we definitely don't know what the skin looks like. But, yeah, we would need specimens where you've got preserved integument, skin or feathers, so we could tell if they had scaly skin or feathers, or both. Some dinosaurs had both. We'll be talking all about feathers in just a little bit, too. That's the next paper after this one. So I'm excited for that, and that'll be a nice segue into Thursday Birds Day here, too. And Crimson Carnotaurus says, "Are they still struggling to figure out where Megaraptorids fall within Theropoda?" Yes. Yeah. We're still not sure, like, where these guys actually belong. Here, go back here. Megaraptoran theropod. Megaraptor is a clade of carnivorous theropod dinosaurs with controversial relationships to other tetanoran theropods. We don't know exactly what part of the theropod family tree these guys belong on. We know that, or we've got a pretty good idea that they all form a clade, a group. They all share a common ancestor. But where do they belong on the meat-eating dinosaur family tree? There's an idea that's been picking up steam recently that maybe these guys are weird southern tyrannosaurs. Maybe they evolved from an ancestor like Stoxosaurus back in the Jurassic. And then they found themselves down in Gondwana on the southern continents, and they evolved into Megaraptorids. So maybe they evolved from like an early tyrannosaur ancestor. Or maybe these guys are more closely related to allosaurs, carcharodontosaurs, something like that. I've even heard megalosaurs proposed, but I don't think that idea is widely held nowadays. Yeah. By the early 2020s, many studies had come to find that Megaraptorans instead represented members of Coelurosauria, with their exact position within this group being uncertain. However, some studies support an allosauroid classification. So we're still not totally sure where these guys belong on the theropod family tree. Yeah. Are they related to the allosaurs and the carcharodontosaurs? Are they a kind of coelurosaur, like tyrannosaurs are? We're not sure. Yeah. So yeah. They belong in a museum, says Mayor Space.
That belongs in a museum.
Yeah, they definitely do. But where do they belong on the theropod family tree? On the theropod phylogeny, as we call it. We don't really know. It's kind of exciting. That's still something waiting to be discovered, and somebody will figure it out. But we don't have a strong consensus on that yet. But yeah. Used to confuse Neovenator as a Megaraptoran? Yeah, Deathsaurus. Neovenator is well, even that guy bounces around. Is it a Neovenatorid? Is it an Allosaur? Is it a Carcharodontosaur? Are those all the same thing? Yeah. Anyway. Yeah, the kitten says, I don't know how much longer I can stay awake. I've got so many pictures for Thursday Birds Day, too. We've got probably at least another hour's worth of science to discuss here before we get to Thursday Birds Day, just to let you know, Chaotic Kitten. So you might have to catch the VOD later on. And that's with me probably ending today's stream early, too. Probably getting to Thursday Birds Day earlier than we otherwise would. But yeah. And doesn't Neovenator also have a big claw on their hands? I don't know, Carnotaurus. I don't know if we know that. Yeah. Neovenator. There we go. I don't know if we have forelimbs from Neovenator. Yeah. There it is, reconstructed as like a Monolophosaurus type dinosaur. Here it is reconstructed as like an Allosaur, basically. But I don't know if we actually have a forelimb from this guy and know that it had big claws on its hands. There we go. Let's see, we've got some skull bits, neck vertebrae, ribs.
Gotta have them ribs.
Ilium. Shoulder joint. Pedal phalanges. We've got toes. But I don't know if we've got any claws or finger bones for Neovenator. So I don't think we actually know if this animal had big claws. But you've probably seen reconstructions like this that show them with pretty big, you know, formidable claws on their hands. I think we don't actually know that. Yeah. So yeah. Yeah. Anyhow. But yeah, let's get back to our video with our Megaraptoran from Australia.
Theropod footprints of about 40 centimeters, and they estimated that to be about a 1.8
Hey, welcome.
tall at the hip animal.
Yeah.
That's this Megaraptoran. That's this theropod. That is getting to 6-7 meters in length. We're now finding not only the footprint evidence, but the fossil evidence as well to back that up.
These 5 fossils represent 3 key theropod dinosaur groups living in Victoria at the same place and time. Yes, there are those Megaraptorid bones found on the beach, but there are also Unalagians or southern raptors.
Yeah.
And
so these guys are kind of spindly, long-legged. They may have actually been wading animals, almost like a big heron or something. But Unalahins, as Matt Lamana says. He works on these guys. Yeah. So, very slender type dromaeosaurs. They may have been primarily like fish eaters. They may have hung out in the water. Yeah. But these guys are known from South America and now, potentially, from Australia.
But there are also Unalagians, or southern raptors, and for the first time ever in Australia, we've found fossilized bones of Carcharodontosaurs.
Yeah, that's exciting too.
Those Megaraptorid fossils on the beach, they sparked a lot of excitement. These were collected, prepared, identified, and described in under 2 years.
So that's actually pretty quick. I guess it's because there's so little material, you could get this sort of thing done pretty quickly. But yeah, in less than 2 years, from being buried in the ground to getting published today, that's pretty darn quick. That's pretty darn quick. Linnea says that's really fast. Yes. Yeah.
We've been caring for this tibia fragment for decades.
This is more typical of how these things work.
It's taken since 1988 to unlock its importance. This one belongs to a small 2 to 3 metre long Carcharodontosaur.
It's special because the Carcharodontosaurs are a group that achieved massive size. They grew up to 13 metres long in the rest of Gondwana, places.
So again, this is what I was talking about earlier. I said we'd get back to Gondwana. Here we go. These southern continents, when Pangea breaks apart, when, you know, all the continents were stuck together at one point, around the time that the first dinosaurs evolved, and then the continents start to break apart. And so, kind of for convenience sake, we separate those into 2 supercontinents. When Pangea starts to separate, there's kind of a big schism between the north and the south. So Gondwana are the southern continents. That's South America, Africa, India, used to be stuck right here. There's Madagascar, Antarctica, Australia, and you get New Zealand and New Guinea. Gondwana. Laurasia up in the north is North America, Europe, and Asia. Together they are Laurasia. Yeah.
It's like South America. And what's strange here is we have a small-bodied animal. Now, the large Carcharodontosaurs were thought to hunt sauropods, your long-necked dinosaurs, the largest land animals of all time. But in our Victorian ecosystem, we've not found evidence of sauropods. So what were the Carcharodontosaurs doing here? It's this sort of...
So what's interesting is they're saying that they've got potentially like a dwarf Carcharodontosaur. Again, they should probably do histo if they really want to figure out whether the animal's full grown or not. They've got 2 specimens. Both of them seem small. They seem very, very small to be an adult Carcharodontosaur. Carcharodontosaurs get enormous in South America. Going back to the 90s, Giganotosaurus is one of these dinosaurs that was, it was all the rage in the 90s, shortly after it was discovered. Yeah. Lovely painting here by Dinotopia artist and author James Gurney. Anybody remember this from the 90s? It was all over the place. It was on the cover of many different books. I don't know. That image, yeah. Pretty iconic. Yeah. So anyway, these guys, Carcharodontosaurs, like Giganotosaurus, Carcharodontosaurus, Mapusaurus, Tyrannotitan, these guys get huge in South America. And yet, this new one from Australia is much smaller. So what's going on there?
Small-bodied animal. Now, the large Carcharodontosaurs were thought to hunt sauropods, your long-necked dinosaurs, the largest land animals of all time. But in our Victorian ecosystem, we've not found evidence of sauropods. So what were the Carcharodontosaurs doing here? It's this sort of upside-down ecology where we're seeing large megaraptorids and small Carcharodontosaurs in this unit.
So what's really weird is in South America, the megaraptorids tend to be smaller, and the Carcharodontosaurs are gigantic. Here, you've got a small Carcharodontosaur and a giant megaraptorid. So it's topsy-turvy. What's going on there, you know?
Sort of upside-down ecology where we're seeing large megaraptorids and small Carcharodontosaurs in this unique Victorian environment.
It's a really exciting time to be working on the problems of uncovering Victoria's dinosaur-aged past. Whether you are walking on the beaches of southern Victoria or working in the centre of a museum collection, there are discoveries to be made almost every day.
Pretty cool. lovely, slick video here. It's really cool when they put the time and effort and money into producing a video like this to help promote this scientific work. Like, hey, we've got this new paper coming out. Let's make a video to go along with it. Let's really celebrate the work that we've done. It's cool stuff. Yeah. Here, before we get into the paper and the press release, let's make sure that Lord here gets paid. Don't want to get evicted. Here you go, sweet pie. Yeah. Ooh. Ooh, look at those. Well, well, well. Yeah, good stuff. And they had 10 plus years, least they could do is a video, says Instafan. No, they had less than 2 years for the new material. But yeah. Have you tried the treat bowl trick with Moon Pie yet? Not yet, Mayor Space. I should. But she's still got the cone on right now. We can try next week. She gets the cone off tomorrow. I'm taking her to the vet. Yeah. Ooh, good stuff, Sweetie Pie. Good stuff. Yeah, more treats. Excellent. How's Moon Pie? She's doing great, Chaotic Kitten. She's healing up really nicely. I spent like 4 hours with Moon Pie this morning, watching her to make sure she didn't pull out her stitches. But I took the cone off and watched her so that she didn't have to have the cone on all morning. And I think she really appreciated that. Yeah. She's healing up very nicely. Isn't she, Sweetie Pie? Yeah. What's funny is that Moon Pie walking around with the cone on, Sweetie Pie doesn't really care, but when Mini Pie sees Moon Pie and sees that cone, she gets scared. She's like, what is that? I don't like this. I think it makes her look larger. You know, it's kind of like, speaking of Australian critters, it's kind of like this. Like an Australian frilled lizard. Look at me, I'm big. Yeah. Anywho, yeah. And is Sweetie Pie... Oh, that's... Mini Pie is the one who's afraid of Eohippus, Mayor Space. Mini Pie is... It's funny. She walks around all kinds of swagger. Anytime somebody new walks in the door of the house, Mini Pie is right there to greet them. Like, hey, who are you? I'm Mini Pie. Come pet me. But she's actually very sensitive. Like, she tries to look very brave, but she gets really scared when, sometimes when things are just a little bit different. Or when she sees a 3D printed Dawn horse. This is life-size, by the way. Eohippus. One of the earliest horses that we have. She gets freaked out by this. If I have this on the floor, Mini Pie walks around the corner, she walks into the room, she's like, what is that? I'm getting out of here. Anywho. Let me give you a link to this video here about these Australian dinosaurs. And let's take a look at the press release, or press releases. There we go. There we are. I think they're pretty much the same. We can compare and contrast. Here we are. Uncanny Valley. There you go, Quasar Shark, yeah. Carnivorous dinosaurs thrived in Australia 120 million years ago. New fossils show. So between 122 and 108 million years ago, the Australian landmass was much farther south than today. This is true, of course. Here. Here we are at present. There is Australia. But go back to 120 million years ago, Australia was right down here at the bottom of the world. Down at the South Pole, basically. It was separated by Tasmania by a vast rift valley rather than an open sea. This was the early Cretaceous, and lush forest filled with dinosaurs dominated the landscape. We still find traces of these animals in Victoria's fossil record. Most of the dinosaur fossils found in Victoria belong to small plant eaters called ornithopods. These are beaky plant-eating dinosaurs. This is like what Holly Woodward was talking about. Some of the dinosaurs that she was working on. How do you spell it? There's another E in there. Lialinosaura. Oh. There we go. It's these little beaky plant eaters. You might remember them from Walking with Dinosaurs. Yeah. So most of the dinosaurs from Victoria up until this point are these guys. These small beaky plant eaters. Little ornithopods. But there are also a few theropod fossils, a diverse group that includes all known carnivorous dinosaurs, as well as modern birds. That's the theropods. Theropods are two-legged dinosaurs. They mostly eat meat. Some of them go vegetarian later on in their evolution. But they also give rise to birds. Birds are a kind of theropod dinosaur. So, Velociraptor, T-Rex, these are theropods.
They were finding fossils.
Maker of Rain, thank you for the follow. Welcome, welcome. It's good to have you here. So more than 250 theropod bones have been found in the Victorian Cretaceous. In the paleontology collections of Museums Victoria, we have now identified 5 theropod fossils of particular importance. Our work on these bones has been published today in the Journal of Vertebrate Paleontology. So, unfortunately, this is an Elsevier journal. Elsevier, however you want to say it. But it is paywalled. So it's not open access. However, I happen to be a member of the Society of Vertebrate Paleontology, and so I have journal access to this journal, so I can show you the actual paper. I can't give you a copy of it. At least not... I can't put a link in the chat, but we'll look at the paper together. Yeah. Research over the past decade has revealed striking similarities between Australian and South American dinosaurs. These include megaraptorids with claws shaped like scythes and small, fleet-footed elasmarian ornithopods. There are also armored parankylosaurians and colossal sauropods with long necks and small heads. These parallels may seem surprising at first, but both continents retained a connection to Antarctica through much of the Cretaceous period. So again, if you want to get from Australia to South America, at certain times, especially when sea level happens to be low, you could walk across Antarctica to get there. And I don't mean like a single animal would walk all the way across here. I mean like over thousands of years, animals could expand their ranges and move from one place to another. You get populations that can kind of move around like that. Our newly described fossils show a bunch of different carnivorous dinosaurs seen in South America also thrived in the Cretaceous of southeastern Australia. 2 shin bones provide the first evidence of Carcharodontosaurs, the shark-toothed lizards in Australia. Again, those are guys like Giganotosaurus. A 3rd shin bone provides strong evidence for the presence of Unalahines, a southern group of dromaeosaurs. Dromaeosaurs are like Velociraptor or Utahraptor, Deinonychus. But the Unalahines, again, are small and... well, they're not always small, but they're spindly. They're delicately built. They're very lanky. A 4th shin bone and 2 tail vertebrae with their chevrons, which are from a megaraptorid, represent one of Australia's largest known carnivorous dinosaurs. A first for Australia. Carcharodontosaurs were apex predators in South America and Africa for much of the mid-Cretaceous. This group of theropods had large skulls, massive teeth, and small arms. They were some of the largest predators to ever walk the earth. Again, that's these guys. They got about as big as T-Rex. Maybe a titch larger, although that's disputed. But they're more lightly built, not as heavily built as T-Rex, not as chunky, and their jaws are narrower from side to side. So despite the success of these guys in South America and Africa, Carcharodontosaur fossils have never been found in Australia until now. With the two shin bones, we now have the first evidence of the group on this continent. Curiously, these Australian Carcharodontosaurs are much smaller than their African and South American cousins, and the bones we have most closely resemble a Carcharodontosaur from Thailand, which is interesting. That's Siam raptor right there, I guess. I'm glad that they linked that here. Interesting stuff. One of the Victorian Carcharodontosaur shin bones was found on the Otway coast. The other was found on the Bass Coast, or is it Base Coast? And rocks nearly 10 million years older. This demonstrates that these predators were successful in this area for at least 10 million years. It's a notable find. I want to know whether they're actually confident that these are adults, because if they're not full grown, maybe that's why they're small. The large-bodied Carcharodontosaurs of Africa or South America were seemingly specialized for hunting long-necked sauropods. However, this food source was likely not available to the Victorian polar Carcharodontosaurs, those ones from Australia. Sauropod fossils have never been found in Victoria. That might just mean they haven't been found yet, or maybe they never lived there. Interesting. Unalahines were lightly built and likely feathered predatory dinosaurs related to Velociraptor of Jurassic Park fame. Most Unalahine fossil remains have been found in South America. Historically, Australia had limited evidence for their presence as well. Our description of a new Unalahine shin bone from Victoria provides robust evidence for their success in polar Australia during the early Cretaceous. The snouts of Unalahines were relatively longer and their arms relatively shorter than those of their dromaeosaur cousins in the Northern Hemisphere. This implies that they had a rather different diet. The Victorian Unalahine presumably ate fish or small land-dwelling animals. One possibility is the small mammals for which the Victorian Cretaceous is perhaps most famous. More than 50 mammal jaws have been found to date, and some are from ancient relatives of the platypus and the echidna. So maybe these Unalahine guys are snacking on mammals. Maybe that's primarily what they're eating. Maybe that's why they've got these long, thin snouts. Yeah. Although we do have evidence that some of these guys were probably eating fish. But why not both? Why not eat little fishes and little mammals too? Yeah. Anyhow. And the apex predators of Victoria. Again, when we say Victoria, we're talking about the... Is it a province or a state? Are they called provinces or states down in Straya? Let me know. I know we've got some Strayans here in the chat. It's a state. Thank you, Rushwing. Yeah. Cool. Large predatory dinosaurs on the scale of Tyrannosaurus are notably absent from the Australian fossil record. Instead, Australian dinosaur populations seem to have been dominated by medium-sized carnivores called Megaraptorids. Wards, it says in Savannah. Prefectures. Districts. Oblasts. Oi. Victoria Oblast? Nar. Megaraptorid fossils are only known from South America and Australia. The most complete skeletons are from South America, including a relatively large one, roughly 9 meters long. Australia's only reasonably complete megaraptorid is Australovenator wintonensis from Winton, central Queensland. Anytime I think of Queensland, I immediately think of dinosaurs because some of the best dinosaur fossils in Australia are from Queensland. Like Australovenator. The shin bone and tail vertebrae we described provide evidence for a large megaraptorid in Southeast Australia, despite being almost 30 million years older than the roughly 5 to 6 meter long Australovenator. From the base coast, megaraptorid was at least 5% larger, approaching the size of its South American relatives. Large muscular arms and fingers tipped with fearsome scythe-like claws were probably the primary weapons of megaraptorids. In contrast to almost every other group of medium-sized carnivorous dinosaurs, megaraptorids had elongated snouts with small teeth. And that is something that we see. Yeah. From the limited evidence that we have, anytime we've got skull material, it seems to show kind of a low-slung snout, not a particularly big head, but big beefy arms, and they may have actually used those arms to subdue their prey. There's Australovenator right there, who is also in our background for today. Yeah. Cool critters. Megaraptor and Australovenator. Yeah. Pretty neat critters. Pretty neat. The abundance of ornithopods, the small beaky plant-eating dinosaurs, all in this case, and Victoria presumably made this region more suited to smaller prey specialists like megaraptorids, rather than the sauropod stalking Carcharodontosaurs. We have much to learn about Australian Cretaceous dinosaurs. That's an understatement. We still have almost everything to learn about Australia's Cretaceous dinosaurs. We don't have a lot of material yet. But this is exciting what we've got today. Our study shows how even 5 isolated and incomplete bones can improve our understanding of our continent's fossil heritage. This is one of those things that I think is really exciting about dinosaur paleontology, is sometimes just a small handful of new bones can change the way that we think about a particular time and place, can change the way we think about a particular group of animals. It can enhance our understanding of a group of dinosaurs so much, just finding a few more bones. Carcharodontosaurs might have been the apex predators in South America, but megaraptorids ruled the roost in the land down under. I do kind of wonder about that, what reason do they have to be confident that the Carcharodontosaur material that they have is actually from an adult? We'll look at that in the paper. The fantastic dinosaur fossil record of Victoria has grown over nearly 40 years thanks to the efforts of Dinosaur Dreaming, an ongoing volunteer paleontology project, and citizen scientists like Melissa Lowery. Thanks to their efforts, our window into Victoria's ancient past continues to become ever clearer. Excellent stuff. And there's a link to Dinosaur Dreaming right here. It's a Monash University and Museums Victoria project focused on fossil sites near Inverloch in the Basque Coast, southeast of Melbourne. Our excavations have yielded more than 10,000 fossil bones and teeth, including dinosaurs, mammals, birds, pterosaurs, turtles, and fish. Very cool. So if you happen to live in Australia, in this part of the world, maybe check this out. Yeah. Really neat. Really neat. Do we have videos here? There we go. Paleontologists hope to find rare polar fossils here on Cape Otway. So they're called their A-team.
Somewhere out here, there should be the leg bone of a carnivorous dinosaur about as big as a fence post. There should be a skull about the size of an engine block.
About 15 years ago, there was a National Science Week lecture that Dr. Tom Rich gave. Somewhere he mentioned that he took volunteers. I said, pick me, pick me, pick me, and they did.
In the summer of 1989, I saw an ad in the newspaper saying volunteers wanted at Dinosaur Cove. I went over there and they gave me a helmet and a set of steel cap boots and said to get in this tunnel and start digging. And been digging pretty much ever since.
I took to it later in life. I'm going to turn 80 this year. I have a mammal named after me. I'm the species, the Mary Walters eye.
I've also...
so she's Mary Walters. What is this? Multi-tuberculate Mary Walters. There we go. Corey Batar. Corey Batar, Mary Walters. This mammal that presumably she found, little multi-tuberculate. That's named after her. That's so cool. That's awesome.
Tunnel and start digging. And been digging pretty much ever since.
I took to it later in life. I'm going to turn 80 this year.
Wow.
I have a mammal named after me. I'm the species, the Mary Walters eye.
I've also found one of the weird multi-tuberculates, which is the strangest looking mammals you could imagine.
I found a mammal jaw about 6 or 7 years ago. My little 16mm mammal jaw is now on display in the Melbourne Museum. So
very cool. And so this is one of those things, you can go out there and volunteer and you might get lucky that day and find a mammal jaw and it's like, wow, there's a new species. Maybe you'll even push back the date for the origin of a group back 10 million years or something. You find the first representative of that group from Australia or something, or the first one from that time period. It's super cool. And it can happen like that.
My little claim to fame.
It's not actually a dinosaur, Coolosuchus. It's a giant amphibian, and it laid in wait around the edge of the water for small plant-eating dinosaurs to have bitten them in half and swallowed the pieces whole. Because I was the discoverer, it was actually named after me, Coolosuchus clevelandii.
Yeah.
While he's prospecting, I was actually responsible for finding this site. I found the first bone here in 2003.
Yeah.
Oh, it's a bit like pulling the handle on the poker machine. You always think you're going to win another one.
You could find a bone today that could be a new...
So, pokey machine, that's Australian for a slot machine, right?
And whenever you find a bone, you're the first person ever to see it, which is quite exciting.
So there are 700 volunteers who've been involved in this dig since it started at Dinosaur Cove back in the 80s. So a lot of them are science students, a lot of them are geology students. Occasionally we get paleontologists and paleontology students, but most of them are just people like me who found a way to contribute to the knowledge of the world without getting one of those fancy degrees, and who come back year after year for the treasure hunt, for the jigsaw puzzle, for the friends and colleagues we find here, and for contributing to what the world knows.
Pretty darn cool. Give you a link to this video right here. Good stuff. Pretty neat. Pretty neat.
This is the site.
And there's that same video. Okay, nice. So again, if you want to work with that group, Dinosaur Dreaming in Victoria, here's a link to their website, dinosaurdreaming.net. Volunteers. So volunteer registration for the 2025 field season has now closed, but I'm sure you could get in contact with them about 2026. It says, if you're interested in volunteering, please contact us. We assembled a volunteer list for February and the preceding October. So if you want to get out there in the summer, February, you got to get ready in the spring, in October. She says one-armed bandits. Yes, indeed. Yeah. Slot machines, pokies. Yeah. Anyway, very cool. Near the water, mowing the tides, mate. I don't know if I know that one, Ms. Art Rules. I don't know if I know that one. That's not the one about tying me kangaroo down, is it? Yeah. Let's get rid of those tabs. Let's take a look at the paper here. So this is going to be in the Journal of Vertebrate Paleontology, which, paleo.org. Unfortunately, it is a paywalled article.
Denied. Access denied.
Yeah. However, I happen to be a member of SVP, the Society of Vertebrate Paleontology. And, that grants me access to the in-house journal, the Journal of Vertebrate Paleontology. So let me log in here. And, remember me, log in. Good. Let's see. Oh, did my membership expire? I guess it did. I only need an online-only journal. Let me go ahead and pay my dues real quick. Oh boy, it's more expensive than it used to be. View and check out. I agree to abide by the SVP Code of Conduct. There we go. Code of conduct. Looks good. Yeah. Here we go. Check out. Okay. Submit your order. There we go. Then I can show you the paper after this goes through. JVP Online Access. Here we go. All right, let's find it. Current issue. There we are. Yes, indeed. View PDF. Beautiful.
Access granted.
There we go. Evolutionary and paleobiogeographic implications of new Carcharodontosaurian, Megaraptorid, and Unenlahine theropod remains from the upper lower Cretaceous of Victoria, Southeast Australia. Yeah, there you go, Rushwing, yeah. So we've already got a pretty good sense for what's going on here. We looked at the press release, we watched the video, all that stuff. Here's a lovely map with some of these fossil localities here. Again, Southeast Australia. Down there, like, just north of Tasmania. And I do really appreciate that they didn't name these as like new dinosaurs just based on fragments like this. We can say with confidence that these kinds of dinosaurs lived in this place, but I'm really glad they didn't try to name a new species or a new genus based on just a couple scraps, you know? Good for them. Paleo, salute for showing some restraint. Very responsible. Exactly, Juanita.
Here's some objects, gorgeous gargantuans and authentic, because though they died out so long ago, their fossil bones remain, so we know just what they were like and can even sculpt them into still, or rather extinct, life.
We live in a society of vertebrate paleontology.
There you go, Steely Dan. Yes. Thank you for the 17 months. Thank you for helping keep me here on the air with that support. Yeah. Is that a George Costanza line?
You know, we're living in a society
of vertebrate paleontology. Here we go. Here's our paper. Let's see. So what I want to know is, so here's that fragment that they have of their Carcharodontosaur tibia. So this is the same bone in multiple views: front, back, bottom. Malleolus, medial malleolus. Okay. It's got some interesting morphology there. Like there's some stuff going on with it. Oh boy. Yeah, the word ontogeny does not appear in this paper. The word maturity, juvenile, histology, nowhere. So are they just... They're just assuming that we've got... It seems like maybe they're just assuming that these are like small Carcharodontosaurs, and how unusual is that? They're so small, you know. I don't know if they're considering the idea that these might just be juveniles, you know? That's, again, I haven't read the whole paper. I'm just doing a quick character search here. Text search, keyword search, looking for ontogeny or juvenile or mature or histology, and none of those come up. Oh. Interesting. So this is exciting, but would be much more exciting is if they were to actually cut some of these bones open. Try and figure out, are these things mature? If you're saying that we've got... How strange is it that these Carcharodontosaurs are so small? You've got to demonstrate that they're not just juveniles. And I don't know if they do that. Characters, keyword search for
ontogeny.
Growth. I did ontogeny. It's... Oh, hang on. Wait a minute. That's annoying. So the Control F doesn't really work. We gotta actually search in the paper. 5 matches for ontogeny. Okay. Alternatively, the presence of the intermalleolar notch in the 3 specimens may be a feature of ontogenetically young Carcharodontosaurians, which are poorly known, although Siamraptor does not appear to represent an ontogenetically young individual. Do they do histo on Siamraptor, though? Although the tibia of Conchovenator is preserved, the morphology of most of the distal end is obscured by a combination of matrix and articulation of the astragalocalcaneum. Further, small-bodied and ontogenetically young Carcharodontosauriae tibia will be required to validate this hypothesis. Okay, so they did talk about it. The search is not working. I gotta make sure that I don't get fooled by that again. The word histology only appears once in the paper, though, and that's in the references, because that happened to be in the title of a paper that they cite. Interesting. Anyway, I'm glad that they at least bring up the idea that, hey, maybe these things are juveniles. But they didn't really go about testing that. Anyhow. Yeah. Anyhow. Yeah. Cut them bones. Yes, indeed, Rushwing. That's how you can get so much more information out of them than would otherwise be available. So anyway, cool stuff. Exciting that we've now got the world's oldest known Megaraptorid from Australia. And Australia's first Carcharodontosaur. There's a link to that press release. Good stuff. Yeah. Anyhow. 2 cool pieces of fossil news today. Let's do one more now. Before we get into Thursday Birds Day. Let's talk about the origin of feathers. And how the origin of feathers remains a mystery. We now know that many different kinds of dinosaur had feathers. But when exactly did feathers evolve?
Ontogeny.
And Plane Shifter in. Thank you for the Prime there. Thank you for the 4 months. I appreciate that, Plane Shifter. Thank you, thank you. Really appreciate that. Yeah. Good stuff. Here, it's kind of a quick introduction to this concept. Let's watch this quick little video first.
When Jurassic Park first came out,
we're not going to focus on Jurassic Park here because we do that a lot. Here we go.
3 years after the first Jurassic Park movie was released, scientists in China uncovered a feathered dinosaur for the first time, Sinosauropteryx. It takes very specific conditions.
Strictly speaking, this is probably not the first feathered dinosaur. Archaeopteryx is a feathered dinosaur, but people didn't really recognize that it was a dinosaur until after further context from things like Sinosauropteryx. That's a constantly recurring theme in paleontology. Is that sometimes it takes a new fossil discovery for you to see a previous fossil discovery in the correct light. For you to go, oh, wait, that makes sense now. We were thinking about this old thing all wrong. Now that we've got this new fossil that kind of hits us in the face with the idea. Back during the 70s, there were some Russian paleontologists who described a dinosaur called Ava Minus. We've known about that critter, again, since the 70s. And there were suspicions back then that it had feathers. believe it's in the miscellaneous theropods chapter. Didn't really know what to make of it at the time. Miscellaneous theropods. So this is gonna look goofy, but here it is right here, Avimimus. Mostly scaly, but also some of those scales are like turning into feathers? What? This restoration of Avimimus is inspired by Kursanov's work of recent years. It is illustrated with a feather-like covering to its body, particularly along its arms. Although many paleontologists are skeptical about the evidence, Kursanov believes that the bones of the arm in particular show traces equivalent to the feather attachment areas on the wing bones of birds, provoking the idea that maybe several theropods were feathered rather like birds. Avimimus is visualized here as a ground-running insectivore, able to catch its prey by speed and perhaps snaring flying insects in its feathered arms. So this has been an idea since, excuse me, since the 70s. And there's the arm bone right there, illustrated. So, it says, the incomplete arm bone, ulna, is one of the most interesting and controversial pieces of evidence relating to the biology of Avimimus. The crest of bone indicated has been interpreted as an area for the attachment of wing feathers. So we've had evidence of feathered dinosaurs since the 70s. We now recognize that Avimimus would look... It's like an Oviraptorosaur type dinosaur. It would look like this. Something like that. Yeah. So it would have looked like a big weird bird. But yeah. Anywho, it wasn't until the mid-1990s that this idea of feathered dinosaurs really became a slam dunk. Here, I'll show you a clip with, I think it's narrated by Matt Lamana, whom we've done fieldwork with. He's a friend of the stream. Good guy, Matt Lamana.
Driving in China is a challenge. Even with an official escort, you quickly learn who rules the roads.
Yeah, sheep do. And shepherds.
In 1995, a farmer named Li Yinfang dug up something interesting in a rural area of Liaoning province in northeastern China. He had found similar fossils here before, but this one was by far the most complete. Li could only guess what it was, so he bought a train ticket to Beijing and took one of the slabs to Dr. Ji Chang of the Chinese Academy of Geological Sciences.
The specimen I got is not the first specimen. That's the third specimen. That, in 1995, the first specimen was found.
There we go.
The local farmer gave it to Nanjing Institute of Geology and Paleontology. They thought it's only a small theropod, that's all.
As he studied the fossil, Dr. G observed a curious feature.
Yeah.
An odd, feather-like fuzz, what we now call proto-feathers, on its body. All birds have feathers, but the animal G was staring at was clearly no bird. So he named it Sinosauropteryx, meaning Chinese lizard wing.
Yep.
It was the first feathered non-avian dinosaur ever discovered in China. And indeed, anywhere in the world. Only the world didn't know it yet. That would take another year, when another scientist from the Nanjing Institute, Dr. Chen Peizhi, attended the 56th annual meeting of the Society of Vertebrate Paleontology.
Again, we're living in what?
You know, we're living in a society.
A Society of Vertebrate Paleontology, in fact. That's the same organization.
Now, if he'd attended the Society of Vertebrate Paleontology meeting that took place in Laramie, Wyoming, or in Bozeman, Montana, or in Norman, Oklahoma, it might not have had the same impact. But the 1996 meeting was held at the American Museum of Natural History in New York. So Chen Peizhi brought photographs of a small Chinese dinosaur with a fringe or frill of feather-like structures running down its back. And he just didn't bring the fossil, just brought photographs. He didn't give a paper, he just walked around showing scientists these photos, and the effect was electrifying.
Yep.
Soon, Sinosauropteryx was making headlines. Over the next several years, Liaoning proved to be a treasure trove as more astounding discoveries were unearthed. Among them were Caudipteryx and Protarchaeopteryx, and Microraptor guii, a weird-looking creature with long feathers on both its arms and its legs. The Liaoning discoveries conclusively demonstrate that feathers occurred on many types of ancient animals, some of which were clearly incapable of flight.
All of these are dinosaurs, by the way. All of these feathered animals are all different kinds of dinosaur.
They also raise a compelling question. If some feathered dinosaurs couldn't fly, how and why did they evolve feathers in the first place?
Yeah, and that's what we're talking about here. To help set the stage further...
Specific conditions for the Earth to record soft tissues like these primitive feathers. The animals had to be buried quickly before decomposing, and in fine-grained sediment. It turned out that this part of China, Liaoning province, saw major volcanic eruptions around 120 million years ago, which provided these very conditions. And more than 30 feathered dinosaur species have been unearthed there and in some other places since 1996.
So it's about 60 or 70 at this point. Maybe even 80 species of feathered dinosaur have been named.
These fuzzy dinosaurs were mostly two-legged meat eaters, part of a group that's closely related to birds in the dinosaur family tree.
Thank you.
That group includes many of the dinosaurs featured in the Jurassic Park movies.
Gallimimus.
These guys probably had feathers of some sort for insulation or decoration.
Yep.
And that includes the raptors. Jurassic Park 3 sort of nodded to the new research by giving them a little bit of a...
Anyway, we now know that Velociraptor had feathers, Velociraptor in particular, because of these quill knobs.
And the Gobi Desert revealed bumps on the forearm, similar to the wing attachments on modern birds. That means the raptors had wings.
Yeah, that's a terrible reconstruction there.
And what about T-Rex?
Really spectacular, spared noise.
Ali J, thank you for gifting Confused Echidna.
J203 gifted a tier 1 sub to Confused
I appreciate
Echidna.
that, Ali.
They have given 96 gift subs in the channel.
Good stuff.
There's no direct evidence, but a few years
when were those quill knobs found? This was, what, 2004 or something this was published?
a velociraptor fossil from the
2007, rather. 2007.
Gobi Desert revealed bumps on the forearm.
That was when it was
Similar to the
published.
wing
I think it was discovered in 04.
That means
Published
the
in
raptors
2007.
had wings. And what about T-Rex?
So yeah, we don't know if Tyrannosaurus had feathers.
The biggest yet so far. Eutyrannus is thought to be closely related to T-Rex, so it's possible that the most famous and feared dinosaur might have been sort of fluffy. It's not clear how universal feathers were among dinosaurs, but while most of the specimens are theropods, there have been a few interesting findings from way over on the other side of the family tree. These two have bristles of some sort, which may or may not...
I don't know if those are actually Psittacosaurus thing. I'm not sure if I buy that, but
bird feathers. And this one, found last year, has even more complex feather-like filaments.
Yeah.
These fossils may indicate that feather precursors date back to some of the dinosaurs' earliest common ancestors.
So yeah, we're not totally sure which groups of dinosaurs actually had feathers. If we've got feathers on marginocephalians and basal ornithischians, things like Culindrodromeus right here, and we also have it on theropods. Maybe sauropods had feathers too. Maybe Thyreophorans. We don't know. But if we've got feathers on theropods and on ornithischian dinosaurs, then that implies that the ancestor of all the dinosaurs may have had feathers. And that's why you've got feathers on these guys who are not closely related. Both of these sides of the dinosaur family tree would have inherited those feathers from their common ancestor. That's where this paper comes in today. That's so there's some context for you there. Crimson Carnotaurus says, haven't scales already been found on a Tyrannosaurus specimen? Yeah, but it's just a small patch, you know? It's not like we've got all of the integument or anything close to that. It's like, I think it's basically like if you were to take a tangerine, take the skin off and flatten it out, we've got about that much skin from a T-Rex. So if we look at dinosaurs like Culindrodromeus, we've got fossil scales and fossil feathers from this dinosaur. So some dinosaurs had both, you know? Do we know what part it was? I don't think we do, Murph. No. No. And Juravenator found with both scales and feathers. I think so, Carnotaurus, yeah. Yeah. So yeah. Wasn't it on the tail, says Petrodactyl? It could have been, but I don't know for sure. There we go. World's only known fossil of T-Rex skin from the neck, pelvis, and tail. Oh, it's from Y-Rex. Interesting, from that specimen. Yeah. I do wonder about that. Y-Rex is a commercial specimen, as I understand it. So some of this stuff, like... That's the thing about commercial digs, is that their incentive is profit. It's not actually collecting good data. Like, first and foremost, you gotta dig the thing out of the ground quickly and with minimal expense. I'm pretty sure Y-Rex was a commercial specimen that was purchased by the museum in Houston, right? Yeah, stored since 2006 at the Houston Museum of Natural Science in Texas, yeah. But yeah. So I don't know. We don't really know whether Tyrannosaurus had feathers and at what different stages of growth. Again, I've talked about this before, but here in Prehistoric Planet, I really like their depiction of T-Rex.
Rex taking a swim.
Where the adult has scales and feathers, although the feathers are very subtle. They're basically like little bristly hairs, like the hairs on an elephant.
With the force of over 5 tons.
If the resolution were better here, you'd be able to see it, but it's got little bristly feathers.
Keen for a taste, but he's not
in amongst the scales. Whereas the babies are fully feathered. They've got these filamentous kind of like proto-feather stage feathers here. Bush Doctor says, do you really think T-Rex could swim? Absolutely, yeah. I would be beyond shocked if it turned out that they couldn't swim. We've got no reason to think that they couldn't. Yeah, like Salamander says, nearly every animal can swim. Tyrannosaurus and other dinosaurs, not only do we have... Well, shoot, here there's a... I'll give you a link to a video about this, because they actually tackle that here. That's what this video is about. Could T-Rex really swim? The answer is yes, certainly.
The skull of Tyrannosaurus fish had an acute sense of swim. But what evidence is there that it ever went for a swim?
Here's a link so you can watch this if you'd like to. I don't want to get hung up on this right now, but Yeah. Anywho, I think it would make a lot of sense if Tyrannosaurus had feathers on its body when it was younger and smaller. Generally, smaller animals who are warm-blooded need more insulation than adults. They're larger. That's kind of a basic physics thing. It might be the square cube law. But like, the bigger you are, the more volume you have, the higher your volume to surface area ratio is. So when you're small, you've got more surface area compared to your mass, so you lose heat faster. Having insulation like feathers might really help you stay warm on a cold night, might be a big advantage. When you're really big, you lose heat much more slowly. And so there's less need for integumentary structures like feathers or fur. Look at elephants, for example. Baby elephants are much hairier than the adults are in general. Adults have got some hair too, but it's much more pronounced on the babies. I wouldn't be surprised at all if the same thing turns out to be true for Tyrannosaurs. But, anyway, does that make sense? Yeah. You think I should grow feathers then, or nah, says Reaper Sage? Reaper Sage, it's probably not gonna work out super well, because feathers, you're gonna see here, feathers are a unique evolutionary feature that only arises in a certain group of animals. Dinosaurs, or maybe dinosaurs and dinosaur ancestors too. We'll see. So birds are inextricably linked to feathers, which allow them to fly, keep warm, and put on dramatic displays. Feathers, however, predate birds, which is important to know. They first belonged to extinct dinosaurs. Finding out exactly when feathers evolved and which animals had them could offer important new insights into the distant past. In the 1990s, the first fossilized feathers were found in extinct dinosaurs. Then almost 30 years later, many questions still remain about these distinctive features. Did all dinosaurs inherit feathers from a common ancestor? Or did feathers evolve multiple times among dinosaurs? Are they exclusive to birds and their closest relatives, the theropods? Or are they more widespread across the reptile family tree? At the moment, jury's still out. With such important details still shrouded in mystery, a new review has sought to bring together the latest knowledge about the evolution of feathers to help find answers. So this sounds like it's going to be a review paper. Any scientists in the chat, you already know this, but for everybody else, a review paper is not necessarily doing new scientific work, but it's just looking through the published literature and trying to figure out what has been written about this topic so that we can summarize it and try and make sense of it. Review papers are one of those things that they don't always bring in funding or prestige for a laboratory, for a group of scientists, for a working group, whatever. But if you want to actually drive the science forward, if you want to help move things along, having review papers published kind of can bring all of your colleagues up to date on, like, shoot, what have we been writing about this? They can help streamline things for future researchers, because when you've got all of the work compiled in one place and summarized, you can tell at a glance who has worked on these things, what have they done, what is the current state of things, so you don't end up accidentally repeating work that's previously been done. You can just start from, what do we know currently? What can we find out beyond that? Rather than trying to reinvent the wheel. So, review papers are really important, even if they're not like the most exciting kind of science. Does that make sense? Yeah. And Plane Shifter In says, so dinosaurs were warm-blooded? Well, shoot, there's a lot of different kinds of dinosaurs with wildly different body plans, different lifestyles, different habitats. Yeah, huge diversity of body form in dinosaurs. And there's probably a big diversity in terms of their metabolism, too. We do have strong evidence that a lot of dinosaurs were warm-blooded. We don't know if all of them were. However, you know, squirt gun to my head, Danny, were dinosaurs warm-blooded? I would say yes. Dinosaurs in general were warm-blooded. But it's going to be a spectrum, you know? So yeah. Yeah. Anywho. Here we go. Are feathers exclusive to birds and their closest relatives, or are they more widespread across the reptile family tree? At the moment, the jury's still out. With such important details still shrouded in mystery, a new review has sought to bring together the latest knowledge about the evolution of feathers to help find answers. Professor Paul Barrett, one of our dinosaur researchers, co-authored the paper alongside Professor Xu Xing. Now, Xu Xing actually shows up in the documentary that we were just looking at.
Place. Yep.
And in some other ones, too. But, here. Where was that? Xu Xing is... one of the most famous dinosaur paleontologists in the world. He is a rock star in China. Trying to find you that clip that helps illustrate this point. Here we go, I think.
Transported to Beijing, these fossils allow 21st century researchers new insights into the feathered dragons. Like Sinosauropteryx, the first discovered in 1996.
On Plane Shifter says there's a correlation between being warm-blooded and having feathers. Yes. Yeah, generally animals don't have insulation, whether it's fur or feathers or whatever, unless they're generating their own body heat from inside. You know? Yeah. In the same way that, like, you put hot soup into a thermos if you want to keep it hot and take it to work, right? Take it to a picnic or something. If you're drinking something that's supposed to be room temperature, you don't have to insulate it. Maybe that's a bad analogy. But animals that get their body heat from external sources, like a lizard basking on a rock in the sunshine, that lizard doesn't need fur or feathers to keep warm. That would actually maybe hinder it, potentially. It's getting its heat from an external source, so feathers or fur would just get in the way, you know? Lizards also wouldn't have feathers because, well, they're not part of the same evolutionary group that evolved feathers. But yeah. Anyhow.
This specimen remains a source of fascination for one of China's most famous paleontologists.
Here we go, Xu Xing.
I remember clearly at that time when this discovery was announced, everyone got so excited, we are kind of shocked by the beauty of the fossil. If you look at this specimen closely, you see the feathers cover the whole body, over the head, over the back, cover whole the tail, a little bit here also, limb. Basically, feathers are quite simple. They are more like your hair. Before this discovery, some paleontologists believe some bird-like dinosaurs should have feathers, but
Jack Horner thought this, for instance, back in the 80s and 90s, before this discovery.
Now we have real evidence, so that's totally different.
Yeah.
The discovery of this feather-covered fossil was astounding. For the first time, they had found a dinosaur with avian characteristics, proof that they were part of the same lineage.
Good stuff. So, Professor Paul Barrett, one of our dinosaur researchers, this is the press release from the Natural History Museum in London, co-authored the paper alongside Professor Xu Xing, who you just saw in that clip. Well, dozens of feathered dinosaurs have been identified since Sinosauropteryx was first unveiled in the 90s. They're mainly meat eaters that are close relatives of birds, explains Paul Barrett. Everyone agrees that these dinosaurs had feathers. There's little consensus beyond that. To settle these disagreements, we need more fossils and to define what a feather is. If we can sort this out, it could reveal where feathers first came from and whether they predate the dinosaurs themselves. The study was published in the journal Biology Letters, which I think is open access. So when did feathers evolve? At the moment, paleontologists are split into a few different groups depending on their thoughts about when feathers evolved. The first group supports a concept known as the Avametatarsalia origin, which refers to the group containing birds, dinosaurs, and pterosaurs. So there is a paper about this not too long ago from some researchers at the Natural History Museum in London. Pterosaurs may have had colored feathers similar to birds. So the idea here is that the pycnofibers, the filamentous integumentary structures, this hair-like stuff that we know that certain pterosaurs had, we have fossils of it, we know that they were fuzzy. The idea is that, oh, this is the same kind of fuzz that we see on dinosaurs, like Sinosauropteryx. Because pterosaurs here are not dinosaurs, but they are very close to the dinosaurs. They share a recent common ancestor with dinosaurs. They are close cousins to the dinosaurs. So the idea is that this ancestor that the pterosaurs and the dinosaurs evolved from, the idea is that this ancestor, that ancestral Avametatarsalia, that had this structure. And both pterosaurs and dinosaurs just received that as an evolutionary hand-me-down. That was a characteristic, a feature that they inherited from that ancestor. That's this idea here. Avametatarsalia origin. This theory suggests that feathers first evolved in a common ancestor of the dinosaurs, including birds and pterosaurs, meaning both groups would have inherited their feathery coatings. Some would have later lost their ability to grow feathers, explaining why some species don't have feathers but are scaly instead. Other researchers believe that feathers evolved at a different time. Some think that feathers may have evolved among the ancestors of dinosaurs, but that the fuzzy features found in pterosaurs are something else entirely. A different thing, independently evolved between dinosaurs and pterosaurs. So yeah, does that make sense? Is this making sense so far? But yeah. And Salamander says, we don't know what specific gene or genes can cause a feather to develop instead as a scale and vice versa. I think that's... I know that the groups are working on that. I don't know how well understood it is, Salamander, but I know it's been a subject of active research. So the Tetnuran theropod origin goes even further. It suggests that only the two-legged meat-eating dinosaurs known as theropods developed true feathers. So that would be only from this branch onward are feathers a thing. Only right here onward. Just the Tetnuran theropods. So things like Spinosaurs wouldn't have feathers. but tyrannosaurs, dromaeosaurs, troodontids, and birds would. Same with maybe allosaurs, potentially. Yeah. One of the main reasons behind these different theories, I would say hypotheses, one of the main reasons behind these different hypotheses is that most feathered dinosaur fossils come from the Cretaceous period, long after feathers would have first evolved. Finding earlier fossils would be crucial to change this. That is an issue. We don't have really hardly any evidence of feathers on dinosaurs prior to the Cretaceous. We have it on Archaeopteryx and on Anchiornis. And we've got it on, yeah, lots and lots of Cretaceous dinosaurs. But if you go back to when feathers may have first evolved, we don't have those fossils yet. We only have later stuff. That's not because they didn't have feathers yet. It's just because feathers are extremely rare to preserve. It takes really, really specific circumstances to preserve feathers. You got to get really, really lucky. You got to have exactly the right conditions, like in the Yixian Formation in Liaoning in China. It's really rare to get that. What's that matrix, says Murph? In a lot of these cases, it's kind of like a limestone. Or like a really, really fine-grained sandstone. You typically don't get feathers in mudstones or anything like that. It's got to be super fine sandstone, often with like volcanic ash mixed in. Or sometimes limestone too. Actually, limestone pretty often. But yeah. Here, in this documentary, I think they talk about that a bit. The kind of preservation that you need, right? Yeah. I don't know if I'm going to find that clip. That's okay. So we need to find new sites with fossilized feathers, particularly from the Jurassic and Triassic, Paul says. The Triassic is especially important, as finding feathered dinosaurs at this early time in dinosaur evolution would suggest that all dinosaurs had an ancestor with feathers. If feathered dinosaurs aren't found among early dinosaurs, then it makes it more likely that feathers were an innovation among later groups. So only later dinosaurs evolved feathers. Yeah, it'd be nice if they had a figure here that kind of shows these three different hypotheses for the evolution of feathers, but I can try and act that out for you. Either feathers evolved super early on, at the common ancestor between the pterosaurs and dinosaurs, right here, or feathers evolved somewhere in here among these theropods, or they evolved at like the base of Dinosauria. We're still figuring that out. But yeah. Anywho. So cool stuff. Again, here. Oh, no, we've got more of it. As well as for hunting for more fossils, researchers will need to agree on the precise definition of a dinosaur feather. While feathers belonging to today's bird species are helpful to refer to, millions of years separate them from those of the dinosaurs, meaning new features could have evolved in the interim. And we have evidence of this, like... Yeah. Kind of different stages in feather evolution. So you go from having just simple hair-like feathers, like this, just one strand, right here, to a central shaft with incompletely fused barbs right there, and you get barbules, and then you get the shaft of the feather evolving, fully developed rachis, differentiated barbules, and asymmetrical veins. Yeah, so we get different kinds of feathers in the fossil record at various stages of complexity. We presume that these are feathers. They're like early proto-feathers, as we usually call them, proto-feathers, but there have been some paleontologists who were like, I don't know if we should call those feathers. We don't know if they're actually ancestral to the fully developed asymmetrical feathers like over here. So to identify a true feather from a living bird, we'd look to see what it's made of and its structure, Paul explains. One of the characteristics we have to identify is that the feather grows out of a follicle in the skin. It's possible, however, that follicles and other modern characteristics might not have been present in all dinosaur feathers. Detailed anatomical work at a microscopic level to compare preserved skin and feathers with examples from living birds could help to resolve this. One promising source of new details is preserved skin. Comparisons between fossilized skin in some dinosaurs and early birds from China suggest that they had similar tissues, supporting the idea that it was present in a common ancestor. Other dinosaurs, however, had more reptile-like skin, or a mix of feathers and scales, which instead make it more possible that feathers evolved independently. Ultimately, there's still a lot of work to do until the origin of feathers can be pinned down. Until then, paleontologists will continue to search the world for the fossils that can finally settle this decades-old debate. So this is cool. They're doing important work here. It's not like they've got a super exciting new discovery, but they're helping to frame this question so that we can actually think about it in a way that makes sense. You know? Yeah. So here's the paper here. The Origin and Early Evolution of Feathers, Implications, Uncertainties, and Future Prospects. And the journal Biology Letters is, of course, open access. So let's open it up here. Here is a link for you there in the chat if you'd like to follow along at home.
Access granted.
So a lot of what we read here in the abstract was already in the press release, so we won't reread this again. But yeah, I don't know if we're gonna have a lot of figures in here. But here, like Salamander was talking about, we actually have discussion of some of the different proteins that are involved with the development of feathers. Various genes and their expression patterns are known to be responsible for differing morphologies in modern feather diversity and their distributions. Retinoic acid is involved in vein asymmetry formation. These molecular and developmental mechanisms are generally consistent with the embryological and morphological sequences of barbed Duracus and a radially symmetrical feather to a bilaterally symmetric feather. Here's various representations, various photographs of like different kinds of fossil feathers. Feathers and feather-like integumentary structures among dinosaurs and pterosaurs. Areas of conflict and potential resolution. Yeah. Oh, it's really nice to have these issues just kind of outlined here. A way to organize our thoughts and talk about what we know and what we don't, and help direct the future study of fossil feathers, future directions. The key outstanding questions in feather evolution remain: the timing of feather origin, the homologies of pterosaur, theropod, and ornithischian integumentary appendages. The two competing scenarios for feather origin, i.e. the avian-metatarsalian and tetanoid theropod hypotheses, imply significantly different phylogenetic and temporal frameworks for feather evolution. Good stuff. I'm excited about this. In fact, I should really read this front to back when I'm done with stream today, just to make sure that I'm fully up to date on the current thinking on, up to date on what we know and what we don't know about the fossil record of ornithodyrine feathers, dinosaurs, and maybe their closest relatives like pterosaurs. Cool stuff. Very cool. Excellent. Wow. Good stuff. And yeah, Sonic Hedgehog. Yes, indeed, Otterduit. That is the name of that gene. It's responsible for a lot of different things. Sonic Hedgehog is extraordinarily important to development. Yeah. Anywho, we've gotten through our new papers published. There's a few more we could go over, but get kind of tired and hungry, and we should really get into Thursday Bird's Time. But before I do, I forgot. Let's take a screenshot, post it to Blue Sky, and yeah. There, we'll open that up in Paint. There we go. First tries the charm. Crop. And the birdie mode in there, that's kind of perfect. Whoever posted that emote in the chat, kudos to you. It looks like it was Wombat Hole. Nicely done. Alright, save as. Untitled, that's good enough. Open up Blue Sky here. Let's post it. Yeah. Almost forgot to post for Thursday Bird's Day. We just discussed the new Australian theropods paper. Earliest occurrence of a Megaraptoran. The Romanian titanosaur. Publication. And the review paper on dinosaur feathers. Now it's time to take a look at some bird photos from the community. Some avian theropod photos from the community. Alt text. The 3D printed Archaeopteryx. Berlin Archaeopteryx specimen. An old school Deinonychus skull in the background amidst other paleo paraphernalia. And then come join us and let's celebrate modern theropod diversity and plumage at twitch.tv/Paleontologizing. There we go. All right.
Hold on to your butts.
There we go. Good stuff. And yes, indeed, the timing on that bird's emote, Lenina, Wombat Hole, you were right on the money there. There's a link if you'd like to engage with that post for whatever reason. Yeah. Good stuff. And celebrate good times. Come on, says Mayor Space. Yeah. Ready for birds? Excellent, Chaotic Time Traveler. Well, you tuned back in at just the right time. Because it's Thursday Birds Day. Let's get into it.
Hold on, something's coming out of here. Look, there's a bird, dude. It knows what's good. I'm telling you, I just heard it inside.
Thursday Birds Day.
Birds are all around us in everyday life. But most of the time we hardly even notice them. Thursday Birds Day is a step toward correcting this oversight. Do you want to be part of Thursday Birds Day?
I don't know.
Here's how you can contribute. Go outside during the week and pay special attention to the birds around you. See if you can take a picture of a bird. It doesn't have to be a good picture, any old photo will do. Upload the picture to the Discord and we will discuss it on Thursday. Simple as that. Thursday Birds Day is an invitation to go outside and appreciate the grandeur of the natural world. It's a reminder that, since birds are theropods, dinosaurs still enrich our daily lives.
It's great!
And finally, it's a celebration of the amazing history of life on our planet. So, happy Thursday Birds Day!
Happy Thursday Birds Day, everyone. Let's get into it. Shoot, and holy cow. We've got so many birds to cover. We might have to do this really quickly today because there's 2 Thursday Birds Days in a row that we had to miss. So this might be a long one. Yeah. We're doing 3 weeks worth of Thursday Birds Days today. So let's get them along. Some galahs outside work in the morning from Dinosaur Dave. Just some lovely psittaciform birds. These Australian parrots. Good stuff. Thank you, Dinosaur Dave, for posting. Excellent. And some of the king penguins at the Detroit Zoo.
Penguins are eating their fish.
From Mayor Space there. Not emperor penguins, but king penguins. The second largest penguin species in the world. Good stuff. Yeah. Very nice. Very nice, Mayor Space. From Miss Capri Kel. Ooh, Canada Goose. That's Branta canadensis right there. And some gulls. I don't know what kind of gulls. No, I know what kind of gulls gulls these are. They're genus Larus. to get more specific than that. Genus Larus. There. Let's look him up on the Tree of Life. Probably ring-billed says Neverwinter. That would make sense. They're pretty common, aren't they? But I can definitely be correct. If I'd... Wait, hang on. Skimmers... Wait, there's gulls that aren't in genus Larus? Creagrus? What? Zama? Rissa? All these different genera. Shoot. Well... Is this genus Larus? This probably is. 46 species? Larus is a large genus of gulls with worldwide distribution, but for the greatest species diversities in the northern hemisphere. Until about 2005 to 2007, most gulls were placed in this genus, but this arrangement is now known to be polyphyletic. Well, I can't use that joke anymore. I can't say, oh, it's genus Larus, because... Anyway. Very nice, Miss Capri Cal. It's awesome to see some birds like this, even in the cold depths of winter. But yeah. Anyway, cool stuff, Miss Capri Cal. There are hundreds of them in the park. Nice. Alexander Morrison says, back when it was chilly in Florida some weeks ago, I heard and eventually spotted a male cardinal. Interesting. Even with the cool choppy winds, this little red avian archosaur will not be hindered from singing his songs. Very cool. They really do sound like some sort of science fiction laser gun. Nice. Very nice. Good stuff, Alexander Morrison. Thanks for posting. Loon 700 has got Gallinula chloropus. Is this a... What are these guys? Is it a coot? Or is it a rail? Gallinula. Oh. Not a less hen, but a more hen. Gallinula chloropus. Are they related to rails or coots? They are. Ding, ding, ding. Red-fronted coot right over there. And then chestnut rail. So they're related to rails and coots. Getting better at this, chat. Nice. Good stuff. Finally, a joke that works. There you go, Thordal, yeah. Good stuff. Fawn Prophet has got a blue jay who is unfazed being swooped by a woodpecker. Yeah, that blue jay is like, I don't care. Come at me, bro. Nice. Yeah. Trying to find an emoji that gets the idea across. Like, hey, I don't care. Whatever. There we go. Sunglasses, that works. Yeah. Dr. Irrefutable's got a bowerbird from Australia. Very cool. Oh, man. These guys are, if we had more time today, I'd play you a video. The bowerbird building that bower, but that's what that structure is called. Yeah. So different species of bowerbird, as I understand it, will build different kinds of bowers. But they do this to show off to females. So the male builds this, and he's like, hey, look at how creative I am. Look at how good I am at building this bower. I've got good genes. Come breed with me. And the blue bowerbird is obsessed with the color blue.
You need to salute the paleontologists.
Sage Star, thank you for the follow. Welcome. It's good to have you. Yeah, so they'll collect all these blue objects as a way to, like, yeah, entice the females. Pretty neat stuff. So there's a bowerbird, Dr. Irrefutable. Yeah. All the blue for this bird. Yeah. Construction there. And your cat Robin has come to join us for Thursday Birds Day. Excellent, chaotic time traveler. I hope Robin's having a good day. Robin's named after a bird. That's pretty cool. Cacklin's Wharf says it's the end of the afternoon. Yeah, California Dreamin'. It almost goes up the song. At Plantswen Oost, the southeastern section of Emserfurt's 1400 city boundary, and the jackdaws, corvids, are gathering en masse to sort out sleeping spots. But when mobilization is once again called for, ooh. Nice. Oh, they're going nuts. They're all trying to find their spots for the evening. Very cool. Because these are fairly small animals, they can afford to all kind of live in the same spot communally like this, or at least they gather at night. It's hard to imagine large theropod dinosaurs exhibiting this kind of behavior. Especially since they can't travel as fast. They can't go for miles and miles and miles with just a few wing beats. They'd have to walk over land. But yeah. Cool stuff. Cacklin's Wharf, well done. Very nice. And Mizart Rules, who is this? Huh. Not like a Vareo, is it? So my bird with the bird art. Yeah, who is this? Anybody know? Sage Star says, do you know the common ancestor for platypuses? Between platypuses and whom? Sage Star, what do you mean? Or do you mean like what was the first platypus that we've found so far in the fossil record? I don't know. It might go back to like the Cretaceous. Yeah. Echidnas are also related to the platypus. Yeah, they're monotremes. Yeah. Sage Star, do you mean what was the first platypus we have fossil evidence for? Or do you mean what's the common ancestor between platypus and another kind of animal? Because if you want to know that, you'll have to name what other kind of animal you mean so we can find their common ancestor. Yeah. And Heox says, hey Danny, I'm curious to know if you saw the Wired YT channel Ask a Paleontologist video. Is that the one with Mark Lowen? Or the one with Paul Barrett? Or there's a few that I've seen the thumbnails, but I haven't watched them. Yeah. Anywho. Little yellow bird, it's cute. Yeah, Western kingbird maybe, says Neverwinter. Western kingbird. Could be. Could be. It does... I don't quite see the white around the eye that I see here, but that's probably what it is. It's probably a Western kingbird. It does have almost a shrike-type beak, and I think kingbirds and shrikes are related, right? Yeah. Let's see. Cassin kingbird, says Mizart Rules. Okay, nice. So, shrikes, and now let's try Cassin kingbird. Cassin's kingbird. Okay, they're not close. Never mind. Not close at all. Interesting. Cassin's kingbird. Okay. Tyrannus. Oh, are these are they related to the tyrant flycatchers? Yeah, there we go. That's such a cool genus name, Tyrannus. Eastern kingbird, Tyrannus. Good stuff. Shared one Zoom with so many people. Yeah, Casey, it's a wonderful resource. It really is. Gotta love one Zoom. Good stuff. So, kingbird. Excellent, Mizart Rules. Thanks for posting. Rushwing has got an Eastern Rosella in my neighbor's apple tree. Still working on getting it to visit my yard proper. That's a gorgeous bird. Wow. It's almost too busy with its coloration. It's almost got too much going on. Chill out, bird. Doing too much. Very cool. Very cool. Nice. Very nice. Good stuff, Rushwing. There we go. Nice. Eastern Rosella. Let's look those guys up on a Tree of Life too. I should have closed that tab. It's going to be related to other parrots, presumably. Looks like a budgie cosplaying as a macaw, says Crimson Carnosaurus. It kind of does, doesn't it? Eastern Rosella. Platycercus. That means flat something, circus. Is that like cerca, like closed in Spanish? Anyway, they're related to various parrots. Cool. Very cool. Thank you, Rushwing, for posting. Neverwinter has got a green heron, Butyrides viruscans, at John Hines National Wildlife Refuge in May 2021. That's gorgeous. Beautiful Neverwinter. Beautiful. Pretty neat. Pretty neat. Green herons are super fun. Herons in general are cool. That reminds me, I was just posting about this on Blue Sky. Yeah. So my Blue Sky feed is like 30% photos of herons. While I'm not upset about that, I am confused about why. I don't know, did I follow hashtag heron or something? It's nuts. Like, it just shows me photo after photo after photo of herons. Yeah. Person says, not all herons wear capes. Agreed. Excuse me. But I don't know. I think when I was still figuring out how to use that website, I must have accidentally pressed the heron button, and now it's all herons all the time. But yeah. Anyway, I'm grateful for yours too, Neverwinter. That's beautiful. I don't know if I would call this a green. I know it's called a green heron, but it doesn't look particularly green. So whoever named that, that's cool. Lenina, you've got a heron emote? Very nice. Hair. That's okay. Danny didn't escape the heron. He did in his past. Can't escape the heron. Hot take, green heron, not green. There you go, Lordy. Yeah. Yeah. See, that's the kind of hot takes that you get here on Thursday Birds Day. It's the sort of provocative content we deliver here. Actually, Echidna, that reminds me of a thing, too. Do you remember those, like, copy pasta things? Here. Yeah. Yeah, where it would be something like, this is back in like the MySpace days. These are also chain emails, but I remember them being big on MySpace. People would send each other these messages, and it's like if you don't send this message to 10 other people, then a scary clown will show up next to your bed tonight, and he'll be holding a knife, and he'll kill you if you don't forward this to 10 of your friends. Where's the heron one? There we go. I am a heron. I have a long neck and I pick fish out of the water with my beak. If you don't repost this comment on 10 other pages, I will fly into your kitchen tonight and make a mess of your pots and pans. I love that so much. I love it. I saw this like embroidered or somehow printed on like a knit sweater at one point. And I wish I'd saved the image because it was one of the funniest things I've ever seen. Yeah. It was like ASCII art, or maybe like 8-bit art of a heron too. very digital. Anyway, let's continue. Confused to Kidness says, joke's on you, Heron. My pots and pans are already messed up. Anyway, thank you, Neverwinter, for posting this lovely green heron. Anywho. Beats International says, was surprised to see this pair of noisy geese perched atop a tree on a residential street this morning. And there goes the neighborhood. It's the geese's neighborhood now. Yeah. What kind of geese are these? I like your alt text there too. Is a pair of noisy geese perched atop a tree in a residential neighborhood this morning. Nice. Oh. That's not alt text. I highlighted that part of the text and that's really interesting. Street this morning? Street this morning. Of. That's cool. Yeah. Was surprised. New Discord feature unlocked. Street. Good stuff. Yeah. It's the geese's world now, says Gravity. It's always been the geese's world. We're just living in it, you know? Since the evolution of geese. Yeah. You mean it's the geese's world? It always has been. Except it'd be funnier if he was a goose holding a gun. Yeah. Good stuff. Beats International, here, salute, and, yeah, it's the geese's world now. Lenina says it's been too long in between grackle picks. Yeah, send grackle picks, Lenina. Here's some hanging out on and around my car at Buc-ee's in Temple, Texas. Oh, so not only do we get to see some cool grackles here, which are very underappreciated birds, but they're very cool. All theropods are worthy of respect and admiration and adulation. But yeah, Temple, Texas. This is where there's that temple built to the official deity of Texas, right? Yeah, here's a graven image of yeah. So this is like the within the Texas culture, the people worship this creature as a god, right? Yeah, Lenina, yeah. That's why it's called Temple, Texas, as well. Cool stuff. Good stuff. I thought the deity of Texas was football. I think that's a competing sect. Sparky Pugwash. I think that's part of... There's been a lot of, like, religious war in Texas over who is the true god of Texas. Is it the Bucky the Beaver? The voluminous rodent? Or is it the football man? What's his name? The robot football guy? There we go. Yeah. The football versus the beaver. Anyhow. I've not spent a lot of time in Texas, but I hear it's a fascinating land of many contrasts. And there's a rich cultural heritage. Many fascinating customs. And yeah. Anywho, let's get back to the birds. Thank you, Lenina, for posting. Love me some grackles. And Cacklin, this, I guess, is from last week. There we go, the 12th. Selection of 7 video fragments from a walk on Holland riding to Soest, the Netherlands. Ooh, who is this? Is that a helmeted guinea fowl? Very cool. That's not native to the Netherlands. Yeah. Very cool. We've got other birds. There's a European robin, it looks like. Some other birds up in the trees and the sky. And then, presumably when it gets dark, the number of birds seen decreases. But I hear birds. You know, some like coots or ducks. Geese? Are those some swans? But very cool. Cacklin, thank you for posting that there. Good stuff. Nice. Yeah. Oh, those were Egyptian geese. Thank you, Cacklin's Wharf. Egyptian geese. Let's go back up to that. Pyramid. Mummy. Desert. No, I can't find a an emote with a pyramid or anything Egypt related. But anyway, thank you, Beats International, for posting that. And thank you, Cacklin's Wharf for identifying that. Very nice. Give you a medal. Tuckahue has got the beautiful Florida scrub jay in its natural habitat. So Florida, presumably, right? The Florida scrub jay, of course, native to Alaska. It's a beautiful bird. You really gotta love jays. They've got so much personality. And I recently put out a suet feeder outside here at the house, and I saw a scrub jay this morning fly right past it. As far as I know, none of the birds have discovered the suet feeder yet, but when the jays figure it out, they're gonna be all over that. They love eating suet. Here we go. Here's some proof. Yeah. Suet's really protein rich, and yeah, birds like jays really like that. They'll get there, says Lynn, yeah. I'm hoping the jays find it before the squirrels do, because it's partly squirrel proofed, but I'm waiting on another part for the squirrel baffle before the squirrel baffle is fully operational. So cross your fingers that the squirrels don't exploit that weakness just yet. Any lovely scrub jay here, Takahio. That's gorgeous. Excellent photos too. You can see we were talking about the complexity of feathers, and you can see different kinds of feathers on this. The picture is so crisp and clear and zoomed in. So those asymmetrical flight feathers, you see the kind of insulatory feathers over the torso, and even these little whisker-like feathers, these single like filamentous feathers kind of around his chin. Almost even see the little eyelash feathers. Hair-like. Super cool. Yeah. Good stuff. Toothbrush. Oh, scrub jay. I got it. Lenina. Okay. Jay. Nice. Yeah. Chaotic time traveler's got mourning doves, juncos, and sparrows. Oh my. Looking for food after the 35 centimeters of snow we received last night. That's very precise. Chaotic time traveler, this is lovely. Look at those footprints left by these mourning doves. Look at those footprints. That's beautiful. We've got some ichnology going on. Even more footprints. Very cool. And who is this? A junco? Huh. And there's Passera domesticus, an English sparrow, aka house sparrow, aka invasive nuisance. But I actually find these birds really charming. I really like house sparrows, even if a lot of people despise them. Yeah. Very cool. Nicely done, Chaotic Time Traveler. This is excellent. Yeah.
Dinosaurs lived a long time ago. They were terrible lizards, don't you know?
Majot, thank you for the 1,000 bits. Really appreciate that. Thank you, Majot. Appreciate it. Thanks for your support. That's excellent. And look at this dove sitting on that rock. That's awesome. Yeah. Looks kind of cold, but trying to stay warm there. It's important to have a rock in your bird bath sometimes because certain birds like to stand on it. They don't like to stand in the water or necessarily around the rim of the bird bath. So having a rock in the center is a good thing to have. That's important infrastructure. I'm sure you already know that, Chaotic Time Traveler. Well done. Yeah. But yeah. And Wombat Hole says I get confused between a dove and a pigeon. So they're both part of Columbidae. Here, let's jump to them. There. I know how to get there even if I don't have the correct genus name. The true dodo is a member of this group, Rhaphis cucullatus, along with solitaires, pigeons. Right here, pheasant pigeon. And then you get doves too. Yeah. So doves and pigeons belong to the same group. Columbiformes. There we go. The doves. Very cool. Yeah. And you were wondering about this distinction the other day too? I don't know if dove or pigeon is a monophyletic group, either one. I think you might have doves and pigeons. Yeah, it seems like all of these are doves. And these are all doves. And these are all... Nope, here we go. We got lemon doves over here, and we've got pigeons like the dusky pigeon over here. So I guess pigeon and dove... It's not like you have pigeons over here and doves over there. It's more you've got pigeons and doves that are members of this family, and some pigeons are more closely related to doves than they are to other pigeons, etc. So pigeon and dove, those terms are pretty much interchangeable, as I understand. Yeah. So there's a shocking amount of color variety in that family. So, well, yeah, isn't it cool, Casey? Yeah. Some of them are super brightly colored. Some of them are very drab. Someone in the chat was asking about the rock dove, aka rock pigeon, aka... I don't know why it zoomed all the way out there to zoom all the way back in. But yeah, rock pigeon, Columbia live. You'd think they could get a better picture. There's only like several 100 million of these in just about every major city on the planet. But yeah. Anyway, the rock pigeon. Feral dove, feral rock dove, feral rock pigeon, or just city pigeon. What's this critter here? Columba livia. Anyway. Good stuff. Thank you, Chaotic Time Traveler, for posting. Good stuff. And Ariana Celestine from earlier this week in the backyard shows bald eagles consuming a dead deer. That's wild. All right, we're going to watch. Oh, this is a Twitch clip. Okay. But yeah. This is Haliaetus leucocephalus, the bald eagle. And they're quite fond of carrion. So, eating dead critters. They do a lot of that. Good stuff, Ariana. Good stuff. Yeah. 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 Neverwinter's got not the greatest photo. We'll be the judge of that, thank you. This is an olive-sided flycatcher, Contopus cooperi. I've never heard of this bird before. In Chester Park, Chester, Pennsylvania, May 2021. The olive-sided is a relatively rare but regular visitor to southeastern Pennsylvania during spring and fall migration. It gets its name from the dark green vest of feathers that distinguish it from similar flycatchers, such as the eastern wood pewee. This is my life bird number 212. Holy cow. That's excellent. Yeah. Very, very cool. Olive-sided flycatcher. Let's jump to them. Here we are. And there we are. Olive-sided flycatcher. Contopus cooperi. Right there. So sister taxon to both the white-throated pewee and the Jamaican pewee. Very cool. Very neat. Excellent. Olive. Yeah. 212. I think someone let me do to a 1 and a 2. But let's... Somebody else can second that 2 there. So we got 2 2s and a 1. Very nice. Neverwinter. Very nice. I don't have binocular. Stuff. P-Bounce, it says, saw a cool blue morph snow goose out birding with a friend today in the rain. The goose was birding with a friend in the rain? That's awesome. And this is a really cool bird. It's always cool to see individual variation in birds like this. When you get an individual who looks different from their compatriots, that's pretty neat. It's pretty darn cool. Scorch Hellfire says, birds are always birding. I suppose that's true. Yeah. Well done. That's really neat. Blue morph. Excellent. Very cool, P-Bounce. Thanks for posting. And Dakota says, look at this blob. Speaking of pigeons like we were, there's Columba livia, a feral rock dove. Dove. Couldn't do puddle, but let's do pudding. Actually, no, I don't want people to think I'm talking about making pigeons into a pudding. I don't do that kind of thing. Not really into British cuisine. Or eating animals for that matter. Pyro Kitty's Tavern says, male great Argus pheasant and great Argus chick. It was so cute. Seen during our trip to Disney's Animal Kingdom last week. Hang on, didn't we have somebody else? Maybe it was you. Post this same individual bird? I love that call. It sounds like a person. One more time. oh, okay, one more time. Okay, one last one. One more for the road. Excuse me. Can we make this an alert, please? I think we can. Casey, can I download this? Yeah, nice. All right, and there's the chick there. Beautiful. This is a very well cared for pair of birds at Disney's Animal Kingdom. I probably saw this same bird while I was there back in September. Yeah. Very nice. Oh, and what did you say there, Neverwinter? Oh, and you there, Golganek? Yeah. Again? Lovely. Yeah. Good stuff.
What you doing?
Nice. Why is it so charming, says Casey Snowart? Well, simple, because it goes... That's why. This bird is so charming precisely because it says... Yeah. Wait, I missed it. How does it go? Oh, Casey, here. If you didn't catch it, here we go. Yeah. Good stuff. W, yeah. Oh, that's lovely. Yeah. Excellent. Thank you, Pyro Kitty's Tavern. That kind of made my afternoon. Good stuff. You can tell I'm getting kind of tired. I'm getting a little loopy here. But that's how it goes on Thursday birthday. Dinosaur Dave says, I'm sharing this here from the TikTok channel, Knuckle Bump Farm. 2 freshly hatched emus without feathers. Yeah, we saw this the other day. Why are they shedding their feathers?
Nice and warm.
Oh.
Nice and warm.
That is so funny. Oh. Very cool. Dinosaur Dave, thanks for posting. Yeah, bald. Good stuff. Yeah, and put a shirt on those birds. Recently took a pair of emu chicks that hatched without any feathers. We've never seen this before and have yet to find someone who has. Just another day taking in the weirdest animals life has to offer. Good stuff. Yeah. Yeah, let's give those birds some pants. Oh, sorry. Posting this here. Yeah. They look naked and cold, says Confused Echidna. Yeah, I wonder if... Hopefully they'll actually grow some feathers once they get a little larger. Yeah. Charlie's Dragon. Is this a house finch? No, a redpoll. A redpoll, Acanthus flammea. Acanthus means spiny or spined in Latin or Greek or Latinized Greek. Snacking on seeds near the neighbor's bird feeder and not being too bothered about me sneaking closer for a photo. I can't zoom much with the camera on my phone. Flammea is an excellent name for it, referring to the bright red of the forehead and throat. Very cool. It was first named so by Linnaeus. Wow. Old Carly Linney. I always find it fun when I discover a species named by him, which isn't uncommon since Sweden and Norway share most of the flora and fauna. That makes sense. Yeah. Very nice, Charlie's Dragon. A redpoll. Acanthus flammea. Yeah, nice. Very cool. Huh. Excellent. Thanks for posting there. Fine. Linnaeus. Sweden. No. No, that's okay. Wait. Pole. Red pole. There we go. Actually. Red. Oh. Yeah. Lovely. Mommy Does has got a bird of prey. Ooh, some kind of a Sipterid. Oh, there's 2. Oh, man. Red-shouldered hawk, maybe? Red-shouldered hawks do like to hang out in trees like this. And that shoulder does look pretty red. I wonder if those are red-shouldered hawks. Very cool. Mommy Does.
I'll just give you my message up front. Try not to go extinct.
Spiffy Juggins, thanks for the follow. Welcome. It's good to have you here. Thanks for following. Looks like a red shoulder. That's the kind I see most often around me, says Mayor Space. Nice. Very nice. Very cool. Red. Chival Rus says seen at Sunset Park in Las Vegas. I know this bird. Who could tell me what this bird is? It's a... It's the municipal bird of Oakland, California, where I live. Mayor of Space got it. Ding, 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 ding. Oh. Yeah. A black-crowned night heron. Yeah. There's a ton of them that live here in Oakland. And they are pretty cool. Yeah. I like that. Yeah. Very celebrated birds around here. The Oakland Black-crowned Night Herons. Is this a, like, sporting team or something? I like that logo. Athletic tee. That's pretty neat. Shoot. I might have to get one of those. I don't know if I have the budget for that, but that's pretty neat. That's pretty neat. Yeah. Whoop, not what I'm trying to do. Shoot. Beak. Crown. Oh, hang on. Black crown. Excellent. Good stuff. Yeah, these guys are fun. I like this pretty. She's like, oop, oop, just kind of walking. Yeah. And fish eater, yeah, they'll eat fishes. They'll eat little invertebrates. They'll eat just about anything, but mostly little fishes is what they eat. Chaotic Time Traveler says the Mourning Dove knows that it is safe from my sister's kitten. Good for you, Mourning Dove. Be bold. Yeah. Unafraid, this dove right here. Even with such a fearsome beast. Stalking it. Nice. I like that you've got these paint splotches on here too, so birds don't run into the window. That's nice. Yeah. Yeah. Very nice. Very nice. Oh, and we should do a salute there too for window safety. Yeah. Miss Capri Kel says, my massage therapist lives in Broomfield, Colorado. The GHO and the Hawk Coopers? Come visit her. Great Horned Owl! That's what GHO means. Okay. These birds come visit her balcony. The Jay was on a hike nearby. Nice. Got 3 real winners here. That's awesome. It's so cool to have birds just visit your balcony and hang out. That's awesome. Yeah. Very cool. Very cool, Miss Capri Cal. I love that. That's awesome. Sedulo says a hawfinch that comes to the bird feeder. In French, we call them gros bec noyau. Literally big-beaked kernel crusher. I like that. It delivers what it promises. Apparently, they feed on seeds and fruit kernels, especially those cherries, which they crack with their powerful beak. They can apply a pressure up to 70 kilograms to break the kernels. Wow. That's a big, chunky beak. Yeah. Very cool. Nice. Very nice. Yeah. I suppose it's not surprising there isn't an anvil emoji. Not the most common implement anymore, anvils. But good stuff, Sedulus, good stuff. Neverwinter's got a very orange scarlet tanager at Tyler Arboretum in Media, Pennsylvania, May 2021. Actually, knowing how different town names are pronounced in the US, it's probably got a different pronunciation. It's probably not Media, Pennsylvania. It's like Medea, Pennsylvania. Tyler Perry presents Medea, Pennsylvania. No, this is not a Baltimore Oriole. Check the bill. It's an orange variant that may be due to a mutation or to a shortage of carotenoids in its diet. Interesting. Interesting. Scarlet tanager. So this is what they're supposed to look like normally. That's very orange. Wow. Huh. That's wild, though. Neverwinter. That's very cool. Let's see. Yeah. Carotenoids, get it? Neverwinter, good stuff. Thanks so much for posting. That's wild. That's wild. Huh. Pretty neat. Pretty neat. Chaotic Kitten's got a bunch of seagulls gathered on the bridge. Picture taken from my hotel room in Pembroke Dock, Wales. Very nice. Look at all those gulls. Guarding that bridge. Good luck getting into this castle here. Very cool. Guard. Wales. Excellent. Very cool, Chaotic Kitten. Thanks for posting. Crimson Carnotaurus has got... What is this? Pet parrot feeding its owner some crisps. Uh-oh. You're gonna get like bird mono doing this. That's gross. Oh boy. Good music in it, yeah. Salamander has got a local resident great blue heron. Sometimes there's two of them. Well, well, well. He is great. I don't know how blue he is, but that's a great heron there. Very nice. Excellent. Two. Blue. Excellent. Oh, there he's taking off. Oh, cool. Yeah, it's so cool to watch herons fly. They just have like such slow, almost lazy-looking wing beats. Like, hey, I'm a big bird. I'm flying here. I'm unbothered. But I'll get there when I get there. And people will notice. Yeah. Very cool. Yogurt Girl says, I got up close and personal with some amazing lorikeets. Amazing lorikeets. At Bird Kingdom in Niagara Falls on Tuesday. Very cool. I had a cup of nectar in my hands and they drank up every drop. One even tried to nibble my ring. That's so cool, Yogurt Girl. That is so cool. Look at these lorikeets. Oh, that's awesome. Very cool. Oh, look how happy they are. Look, you look like you're almost in tears. I probably would be too. That's awesome. Thank you for posting, Yogurt Carol. That's excellent. Yeah. Here, Ring and Lori. The lorikeets. That's awesome, Yogurt Garrel. That's awesome. Thanks for posting. Trying not to cry. Yeah, I can tell. I can relate. I would also be overcome with emotion, I think. Neil's got one of my favorite birds, the white ibis. Very nice. Look at that. It's really interesting how there's just this semicircle formed by the trailing edges of all the wing feathers. I wonder why that is. Part of me also wonders whether, you know, when you look at birds like this, especially large birds, the tips of the flight feathers, the distalmost flight feathers, the ones on the ends, they tend to curl up a little bit. I wonder if it's the same thing as, like on airliners. Nowadays, almost all of them have got these winglets like this. And it's to cut down on vortices. From, like, when I was a kid, planes didn't have this. This is a recent innovation. But it helps make the planes more efficient. I wonder if there's something going on with birds like this, too, like this ibis, where the tips of the wingtips go up a little bit at the very end. As usual, nature did it first. There you go, Isolated. Maybe. Yeah. Reduces turbulence. Yes, indeed, Mayor Space. Yeah. Huh. Very cool. Oh, and, oh, here. Airplane. Taking off. Airplane coming down. Wing. How have we never used the wing emoji yet? That's applicable for so many of these. Now we know it exists. Excellent. The planes had them when you were a kid. The C-17 Globemaster III have interesting carnivores. Okay. Huh. Anyway. That is our last bird of this triple session for Thursday Birds Day. Excellent. Thank you, everybody, for your contributions, for your enthusiasm. Thanks for celebrating theropod dinosaurs with us today. That was a lot of fun. I'm tired and hungry, and it's time to wrap up this stream. So, let's run our credits, shall we? We'll find somebody to raid into. Oh, Nerduino is on now. Well. We'll go see what he's up to. Let me make sure that we're not raiding in before he's actually live. Nope, he is good. Well, everybody, happy Thursday, Birds Day, one and all. Thanks for being here today. Thank you to everybody who's being named in our credits. Subscribers and resubscribers, thank you for your financial contributions. That's the only reason I can stream as often as I do. It's the reason this is my full-time job. Thank you for making that possible. Thank you to the gifters and the cheerers. Thank you to the new followers. Thank you to the raiders. Thank you, moderators, for helping us maintain a safe and welcoming community. It's all ages appropriate. I appreciate you very, very much, mods. Hope you all have a wonderful weekend. Again, tomorrow's Friday, so no stream tomorrow. But I'll be back on Monday with probably some more fossil news, more Q&A. We'll see what we've got going on next Monday, but I'm excited for it. You all take care of yourselves, and let's go see what Nerduino is up to, doing some sky watching, some astronomy. Let's go hang out there. See you later. Have a good weekend. Bye-bye.